a tour of the Seabull Dinosaur Complex. And right now I have Laurdee with me.
Hey everybody.
And iios.
We're here. Oh my gosh, we're here. I think we're here.
So yeah. Here's chat right here. Yeah.
Team swap over yet. Yeah.
It hasn't swapped over yet?
We are, no.
Okay, cool. Alright, so people can see you.
Yeah.
Okay. Again, welcome to Paleontologizing. For anybody who is new here, my name is Danny Anduza. I'm a dinosaur paleontologist. I used to work at this museum, and I dug up some of the dinosaurs that you're about to see over on display. So I am very, very excited to share this with you today. Let's go ahead and get started. Right here, this is just at the very entrance to the Seabull Dinosaur Complex. We've got some cool little kinetic displays talking about different Earth processes and that sort of thing. Earth cycle, water cycle, rock processes, really cool stuff. And then, of course, we have this wonderful timeline over here, going all the way from the Precambrian Eon up until the modern day over there, where iios is standing.
Sorry.
It's okay. Yeah. So this is a very Montana-centric museum. Most of the stuff that you're going to see here is from the great state of Montana, and a lot of it represents kind of the bleeding edge of dinosaur science right now. Cutting edge stuff. So I'm very, very excited to show you. So let's get to it. All right, to start with, let's go on over here to the Precambrian Eon. I've always really liked this little entrance right here. Like tunnel kind of ushering us into the museum. And we'll take a look at some geology to kind of lay the groundwork for dinosaurs. Of course, the dinosaurs are the main attraction here. But you can't really understand the dinosaurs without their context. And to do that, you need geology. So here we've got a lovely display about the Beartooth Mountains through time. So these are not too far from where we are right now in Bozeman. Down here, the Beartooth rocks are among the oldest in the world. They go all the way back to about 3 billion years old. That's only 1.5 billion years younger than the Earth itself. And then, we've got some seafloor and estuary deposits, lake and river deposits, mountain volcanoes, glaciers. I would dwell on this a little bit longer, but I don't know. I'm kind of eager to get to some of the fossils over here, including right here. I think we may have talked about this a little bit earlier about stromatolites. Here are our first fossils in the museum. Living, breathing rock, the display says. And these, I think, are models of stromatolites. Stromatolites are these cool, kind of concreted, layered cyanobacterial mats. So these photosynthetic bacteria.
That's so cool. Oh.
Yeah. Isn't that neat?
They're really mat-like.
Well, they are, yeah. Because, just layer by layer, they build up over time.
Wow.
And, they kind of form rocks. This is almost like a proto-coral reef, but it's made of bacteria, bacterial mats. So some of the stuff that we saw yesterday in Yellowstone, iios, is related to the cyanobacteria that make up stromatolites like this. So very, very important. These are among the organisms that oxygenated the atmosphere. So before, Earth's atmosphere was very, very oxygen poor, and you could probably consider that like the first actual major mass extinction. Just when all of these creatures that breathe nitrogen or carbon or whatever, suddenly there's all this oxygen in the atmosphere, which was a poisonous gas to them. And that's thanks to critters like these bacterial mats, these stromatolites. So pretty cool. And you can still see them. You can still find stromatolites like this alive today in places like Sharks Bay in Australia. And there is a photo of them. These are, stromatolites are very vulnerable to, critters eating them. Like snails will wreak havoc on stromatolites, but apparently Sharks Bay in Australia is just saline enough, it's salty enough, and things like snails can't really make it. So yeah, it's one of the few safe havens left for stromatolites. Other places like Yellowstone, you've got these bacterial mats that form, and I guess it's the temperatures there that actually protect them. Those are like extremophile bacteria that form mats. A little bit different from stromatolites, but still very cool. And yeah, earliest life, a microbial world. With iios and laurdee for scale here. And if you two have any questions along the way, please let me know.
Okay.
Yeah, it's going to be part of this, I hope. But yeah. Now, let's see. All right, let's get into some of our first animal fossils here. I've always really loved this display. This is of the Burgess Shale, which is not from Montana per se. This fossil assemblage is from British Columbia, from, I think, Yoho National Park in British Columbia, in Canada. So north of us here, and to the west. But, yeah, the sign says all the ancestors. You can see it right there. So a lot of the ancestors of modern groups can be found in this assemblage. These are about, well, I guess these are about life size, or maybe a little bit smaller than that, maybe half size. This big critter right here is called Anomalocaris. This is the biggest predator in its ecosystem. We saw this same critter at the Museum of Ancient Life in Utah. Yeah, as I said before, if you caught that broadcast, this critter right here, Anomalocaris, its name means strange shrimp. When it was first found, it wasn't found all intact. There were, it was in pieces.
On your phone, I need to update your stream title.
Yeah? Oh, shoot. Yeah, I totally forgot the stream title.
No worries.
Thank you, Ios. My rhythm was all thrown off for today. But yeah, so this critter right here.
How do I use Android? Oh my god, I have no idea.
All right, let me do it. Let me do it.
Okay, sorry. We'll just man.
Okay.
We're just gonna hang out and look at the display for a little bit.
Let's see here.
Some really incredibly strange creatures. Honestly,
They really are.
these little. My shadow is in them a little bit, but like some of the worms at the bottom.
Yeah, not worms, actually.
They're not even worms. Yeah.
No, they're not. So hardly anything that you see here is actually what it looks like.
Real interesting.
Yeah.
Very interesting.
I'll show you in a minute.
Well, it's so good to see all of you from Montana. Genuinely. Really special. And how long ago? This was 530 million years ago. Okay.
Yeah, so it's over a billion years ago. Excuse me, 500 million years ago. Over 500 million.
Sorry. These little like animals with spines along their back are kind of wild to me, honestly.
Which ones?
The Wiwaxia.
Yeah, those are so weird.
And the annelid worms, which are not worms. Thanks for hanging out, everybody. We're going to get the stream title updated. Affiliation unknown. Does not appear to be related to any animal now living. Interesting. Yeah, I'm super excited to be here at Museum of the Rockies with Danny and all of you. I've heard many a story about Danny's tenure here in and around Museum of the Rockies. And it's a really chill museum on a certain level. You don't even have to have a sticker to come in. It's an honor system. It's great. It's great.
Almost done with the title.
I'm sorry, I'm talking a little quiet, but it's just because we're indoors and I don't want to disrupt other visitors. Can we move away from this display just a tiny bit, so in case other people...
Sure. Okay.
I'm following you. Just a tiny bit. Oh, this is a good one. Check out this display. Yeah. So we went to another museum in California that had displays in resin. Okay, I said it. I'm hearing it. Okay, it's resin. It displays in resin. These ones are not like that, though. They're hung from strings, I think.
All right. Update. Okay.
Okay, cool.
Stream info updated
Beautiful.
successfully.
Okay, thanks everybody for hanging out while we got that.
Yeah,
So
we will
excited
go
to-
explore the Burgess Shale
Yes.
exhibit again in a second. Because there's some cool stories there.
Yes, absolutely.
All right. There we go. All right, everybody, please enjoy the new stream title. Sorry that got messed up for a second there. But here. We'll just wait for these folks to move for just a second. What do you think of the museum so far? You haven't even.
I think this is really cool. I mean, I'm just kind of busy reading the plaques and taking it all in.
We haven't even seen any dinosaurs yet.
I
So
know.
wait until that.
Nana Tyrannus says, Danny, looks good.
Oh, thanks, Nana. Appreciate that. Yeah. How you doing, by the way? Hope you're having a good day. Let me shorten this a little bit because we might be in close quarters.
Android is below iios, yeah. Exactly, Mojo, exactly.
All right. I'm just staking out a spot over here. But yeah, again, here is the Burgess Shale. This is one of the most famous fossil assemblages anywhere in the world. And this is one of our earliest glimpses into, like, you know, early animal life, back from about 530 million years ago, right about that. This critter right here, Anomalocaris, is like the chief predator of this time and place. And the largest creature from this environment, too. Its name means strange shrimp, because when it was first found, it was discovered in pieces. And each of these different pieces were given a different name because people thought they were just animals unto themselves. Everything in this environment is so bizarre and strange that it's been really difficult to make what's what out of it. But those appendages in the front were thought to be like shrimps. So that's where the name Anomalocaris came from. Somebody found the body and they named it something else. They found those weird mouth parts underneath. It kind of looks like a camera shutter. Yeah. But really, the creature in this display that's nearest and dearest to my heart, maybe for selfish reasons, are these little kind of translucent white guys right there. You see those? Those are called Picaya. And those are very close to yours and my relatives. All backboned animals evolved from something that looked very similar to those little guys. They were very inconspicuous at the time. They were not a major, like, big ostentatious part of this ecosystem. But every animal with a backbone today, everything from you and me to frogs to whales to bats, all came from something that looked a lot like that. Pretty cool. So from very humble origins, dominant creatures on Earth. Pretty neat, right?
You're right, it is.
And then over here we've got a display of an Ordovician fauna. I'll show you real quick. We've got some nautiloids, kind of a squid in a cone type of deal there. To modern octopuses. And it's interesting, like the predator-prey dynamics going on here. So you have one of these nautiloids, or orthocones, eating a dead Dunkleosteus. This is one of these fishes. It's got these big armor plates all over its head. This is one of the first jawed vertebrates. And then you've got a bigger Dunkleosteus. It's going after these guys here. Circle of life. And then you've got these crinoids right here. I know some of you in chat have collected crinoid fossils before. This is pretty similar to what they would look like in life. These are not plants. These are a type of animal related to, like, sea stars and that sort of thing. So they've got these arms that kind of wave in the current, and then those little filaments will pick up bits of food, and they get passed down to the mouth that's in the center of the, like, flower part there. Pretty cool, huh? I like that display a lot. And then we've got some cool elasmobranch fishes over here that I'll show you in just a minute, before we move on to some dinosaurs shortly. Yeah. How's everybody doing so far today, by the way? I hope everybody's been having a good day. Can you hear me okay? I hope you can. We've got a very cool display right here. So this is a fauna from western Montana. So all of these different fishes and invertebrates that you see here and planty things are all from, what is it called? Bear Gulch fauna, I think. All of these weirdo fishes and stuff.
This is
check
Laura
out some of
during a
these
Jurassic Park.
ancient
Digging up
sharks.
dinosaurs is
Elastic
hard,
brain fishes
frustrating
related to
work.
modern
It takes
sharks.
months or years,
Really cool.
so
Some of
leave it to
them
the
have
professionals.
these weird projections coming off the top of their heads. Those might be sexually dimorphic. It could be that the males had them and the females didn't. And that might be the case with these bigger guys, too. There have been a bunch of different hypotheses as to what those would have been used for. Like, is it something with prey capture, or is it something with, like, I don't know. But it turns out they're probably for, like, a courtship display. It's either visual or might be a tactile thing. I'm not really sure. But yeah. So pretty neat. Oh, and these right here. My favorite critter in this display is kind of one of the less prominent ones. Here, Laura, do you see these guys down here?
The ones that is being eaten?
The one that's doing the eating right there.
Eating, yeah. What
Yeah.
is
Do you know what that is?
that? Is this coelacanth?
It is a coelacanth, yeah.
I recognize that.
Very good,
That,
yeah. So these guys go way, way, way back in time. So coelacanths, it's a really cool story. Does anybody know the story of the coelacanth? I'd be happy to recount it real quick for you. So these fishes have been well known as fossils for centuries. And we've known about coelacanths for a very, very long time. And they've got these really cool kind of lobed fins like this. They've got that really cool heterocircle tail. They're very different from fishes living today. And this is kind of your like archetypical like fossil fish. Really well known as a fossil. But everybody, they sort of disappear from the fossil record at the same time that the non-bird dinosaurs go extinct 66 million years ago. And everybody had always assumed that these creatures went extinct along with the dinosaurs. It's like, of course they did. Lots of things go extinct at that time. Until, in 1938, there was a naturalist down in South Africa by the name of Marjorie Courtney Latimer. And she was out at a fish market on the east coast of South Africa, kind of looking at different fishes and stuff and taking notes. And she sees this great big blue fish for sale. And she goes, holy cow, what is that? I've never seen anything like it. She purchases it, and she pays a very unhappy taxi driver to load it into the back of his cab and drive it back to the museum for her. And, she does some sketches, and she sends it off to one of her ichthyologist friends, sends the sketches back to one of her ichthyologist friends in England. And he says, holy cow, you found a coelacanth. These fishes that were always assumed to have been extinct, thought to have died out 66 million years ago. It turns out they're still around. Yeah. So there's a population of coelacanths. They're kind of famous now. Between like South Africa and Madagascar near the Comoros Islands. And there's another population, another species off the coast of Indonesia. These are super special fishes because they're very closely related to the origin of land-living vertebrates. These fins that they have there, see how there's kind of like a fleshy part coming out, almost like a limb before it gets to the, kind of thin part of the fin? Those are very, very similar to our limbs. And the first limbed vertebrates evolved from a fish that wasn't too different from that. So you can think of that fish as being like, a sibling of your great million times great grandmother. Pretty cool. Yeah. You having a good time?
I'm having a great time.
Okay, cool. But yeah. Let's see. And how many people do we have watching right now, by the way?
Like
Just out of curiosity. Yeah?
60-something, 70?
Not too bad, yeah.
82.
Things are growing as we're getting toward the dinosaurs, which is good. Right here, this is not a dinosaur, but this is an ancient Nectridian amphibian from the Permian period. Check out that weird-looking head. Laurdee, do you have any ideas what that head would have been used for?
Digging in the mud.
Digging in the mud?
That's my guess. Digging in the mud.
That's a solid guess right there. Yeah. And there are a lot of modern amphibians do hang out in the mud. So yeah. It's still kind of a mystery what that was for. But these guys, they lived, long before the dinosaurs, at the same time as Dimetrodon. I think this might be a little smaller than life size. I think they get bigger than this, just to give you a sense of scale. That head has been a mystery for a long time. Why did it evolve this really weird kind of boomerang shape? It's just so bizarre. But there might be some clues to that on the rest of the head. You see how the eyes are on top of the head right there? And the mouth is underneath. Yeah, that might have something to do with it. Some older hypotheses are that these would have been used in fighting. They'd like swing their heads from side to side to hit each other with them. Another idea is that it would make it more difficult to swallow this animal head first, so like it would be a predator defense thing. But take this with a grain of salt, because I don't work on these guys, and I don't necessarily know the latest consensus on them. But I think there's kind of a growing understanding that this is hydrodynamic. These are basically like hydrodynamic fins. If the animal's at the bottom of like a fast-flowing stream or something like that, kind of looking up with those upward-facing eyes at some prey, that if it sees something that it wants to grab, it could just kind of tilt its head up, and then the current would just kind of jet it up to the surface, and it could grab whatever it's after. I'm sure there need to be some more like hydrodynamic studies to see if that actually works. It's a testable hypothesis, which is really cool. Yeah. Diplocolus, or Diplocerapsis, actually. Diplocerapsis is this one here. Diplocolus is the more famous one. These two cool nectaridian amphibians. And right here, check this out. Does anybody in chat know what this is? Yeah, there you go, Truzette, exactly, yeah. Mayor Space, I like that. Yeah, these guys, they probably weren't truly boomerangs, but I don't know, the head shape is reminiscent of it. Yeah, so this is Knives 9, you were right, it is indeed a dinosaur. This is our first dinosaur of the tour. This is one of these cool Hesperornithian birds. This is either Hesperornis or maybe Baptornis. But people ask me all the time in chat about like swimming dinosaurs, ocean dinosaurs. This is usually the one that I bring up. So this is a bird from the late Cretaceous of North America, back when there was a big seaway in the middle of the state, or in the middle of the country, which I'll show you in a few minutes too. These guys were fully flightless and adapted to life in the sea. You can't even see the wings on these guys. They're like, the wings are like this big. They're just like little triscuits. And those feet were used for swimming. And look inside the jaws right there. What do you see? There's some teeth in there. So a lot of birds during the Mesozoic era, during the age of dinosaurs, still had teeth. They hadn't lost them yet. So they inherited those teeth from their dinosaur ancestors, and only later do they lose those teeth. These guys still had it. Teeth probably would have been pretty useful for catching their fishy or cephalopod prey, you know? So yeah. And here we've got a viewing lab right here. Got some hadrosaur tib and hadrosaur femur. Some duck-billed dinosaurs. This is the viewing lab right here. So this is not where most of the real work takes place. All that's downstairs. I used to work in there. But this is some really cool stuff for the public to see. Right there we've got some Troodon eggs. That is a real Troodon nest that you were looking at right there. From Egg Mountain, up near Shodo, Montana. Very cool. And there's a 3D scan in progress. I bet you this is something to do with... I bet you're either Dave Verricchio or maybe Jason or Willie are working on this. Pretty cool. Anyway, you still having a good time, Madison Laurdee? Okay.
Definitely. Yeah. We've just been hanging back.
Okay.
There have been some extra families here.
We want to let all the
that.
kids get in.
Yeah,
Stuff like that. So having a great time.
Oh, and they used to have a big old table right here with a bunch of like dinosaur toys for kids to play with. They must have taken that out during COVID. Yeah. Take a look at a few more of these displays real quick. We'll go up and see some mammals very briefly, and then we will continue on into the Siebel Dinosaur Complex. I'm very excited to show you some of these dinosaurs. This is one of the best dinosaur museums in the world, in my opinion. And I'm going to show you why. But yeah. We were talking about birds a second ago. This is the same Archaeopteryx that I have
It looks almost identical
at home. It is.
to your print. Yeah.
Yeah, this is the the Berlin specimen of Archaeopteryx. Yeah. Very, very cool. You can see those feather impressions. But I don't know, I've shown you this a million times. But here it is here in the museum. Yeah. This was such an important fossil because it helped show us, the link between reptiles and birds. They didn't realize it at the time, but this was a dinosaur. So now we recognize this as the link between dinosaurs and birds. But at the time, back in the 1860s, it was clear that reptiles and birds are related. And then we've got cool plesiosaur skull. Very cool. Look at those teeth right there.
It's incredible.
Yeah, pretty impressive. It's interlocking teeth. I still don't know exactly what these guys would be eating. In this picture, it shows them chasing a shoal of fish. Do they mostly eat fish? Do they mostly eat squid? Do they mostly eat things on the sea bottom? I don't know. I don't study these guys, but pretty big orbits, so would have had fairly large eyes. Probably pretty good vision. And check out those teeth. Big interlocking teeth right there. Very, very cool. All right. Let's go on up to the Mesozoic overlook, and we'll check out some mammals, and I'll show you what we're about to see in terms of dinosaurs, too. So, as I've said before, this is primarily a dinosaur museum. There are some other critters here in collections, too. There's some, Mesozoic reptiles, there's some Mesozoic mammals, there's some Cenozoic mammals, and we are going to see... They changed all of this, never mind. Well, apologies to any mammal people here in chat. But, I guess we're not going to see some mammals. This used to be the one place in the museum where you could see just a few little mammal fossils. Most of them are like this big. But this is all new, wow. I was not expecting to see this. So I moved away from Montana in 2018. Almost exactly 3 years ago. And this is new anytime since then. Pretty cool. Yeah. I wonder if John had something to do with this. Yeah, this talks about making a field jacket. I've still got one of these days I'm going to do a full presentation live on stream of how to make a field jacket like that. These are the jackets that we make in order to help protect fossils in the field and bring them back to the laboratory in one piece. Yoshi Katsura found these Triceratops pieces.
Wow, yeah, and you are acquainted with them, right?
So Yoshi found Yoshi's trike.
Right.
I've never actually met him.
Okay.
But, helped excavate one of the Triceratops that he found. He found it back in 2010. 3027, these are pieces of Yoshi's trike, actually. Yeah. Wow, your first glimpse of Yoshi's trike, everybody. Really excited about that. And here we've got a Hadrosaur pelvis. Very cool. Brachylophosaurus. It's a duck-billed dinosaur from the Judith River. This is funny. Collector N. Murphy. Mm-hmm. That's Nate Murphy, who's a commercial fossil collector. This is probably one of the fossils that we seized from him because he collected it illegally.
Really?
Yeah. Again, Museum of the Rockies is a federal repository for fossils. So if fossil thieves or smugglers get caught, a lot of this stuff ends up here. I think this is one of those specimens. Pretty funny. And there we go. We've got a tibia from a Tyrannosaurus right there.
Yeah, the sectioning is so cool.
Yeah.
Really.
Yeah, this is really important. So something we're going to be talking about again and again, especially when we get over to the Hall of Horns and Teeth, is histology. So that's, taking sections out of these fossils, and then kind of like this section right here. And then if you take like a tiny slice of that and you grind it down, you put it onto a microscope slide, you can shine light through it, then you can actually look at the growth rings inside the bone. And this is critically important for understanding dinosaur biology. Here's some illustrations, some photographs of how that works right there. But paleohistology is a huge part of the research that was done here at Museum of the Rockies. And you will see in a little while why that is so important.
Peter Steves asks,
Yeah.
do you have some of your stuff in a museum / hope to have it in a museum?
I have some of my stuff in this museum here, Peter Steves. I can't wait to show you. Yeah. Yeah. Oh, and here are some. There's more of your resin there, iios.
Resin is just a fancier way of saying rotten. Let's be honest.
Yeah. There's a wafer-thin section of Rex tibia right there, prior to grinding. And there it is. See it there on the right?
Dig up dinosaurs?
Light shining through. So that's how we can actually look at the growth rings in these bones. I know I've talked a lot about this on this channel
know
before.
what it's like.
That's how we do it. And the whole process of creating, a histological section like that it's really labor intensive. It's really as much art as it is science. But it's so important. And this talks about the collections a little bit. Yeah, there's the collections downstairs. These big old compactors. All these drawers full of fossils. I think Museum of the Rockies remains the largest collection of dinosaur fossils in the country. So, yeah, pretty cool. And there is an Orodromius foot right there. It's this cool little ornithopod dinosaur. Its name means mountain runner, Orodromius. And I didn't recognize they were so small. I mean, that's a pretty small one right there. Pretty neat. Yeah. So cool, yeah. It's funny, I used to when I would take tours here, I would show people this little balcony first. I'm like, we'll talk about mammals a little bit. We'll get the mammals out of the way. And then we'll go down and see the dinosaurs. That's Allosaurus. Yeah. That is... It doesn't belong around. That's good eye, yeah. This is actually Big Al down here. This is a cast of Big Al, but we'll see his actual bones down there on the other side of that wall. So yeah. All right, let's go see. And Mojo, this place is big, yeah. It's the biggest dinosaur museum in Montana, and certainly not one of the biggest in the country, but it's big, for sure. And the number of things downstairs in the collections, you could make this museum 10 times bigger and still not put everything on display that's in the collections. It's pretty cool. Dinosaurs under the big sky. Montana is known as Big Sky Country. I don't know, the skies seem pretty small while we've been here, though, huh?
Yeah,
all the smoke in the air.
Smoky, yeah.
Yeah. But anyway, that's my old advisor right there, Dave Verrecchio. Look at some Troodon specimens. I really love the way the displays are written here. They're done really, really thoughtfully in a really unpretentious way. And I don't know, a lot of them have citations with actual scientific papers and stuff. I don't know, it's just top notch. Really, really well done here. Here, you can actually touch some fossils right here. Got a bit of Triceratops brow horn. And
These real fossils?
yeah. And a mammoth tooth right there. Pretty cool, right?
So old.
Yeah, so that Triceratops horn, it's probably Triceratops prorsus. It's probably 66 to maybe 67 million years old.
So when they would choose a fossil to put on display like this,
Yeah.
is it something that maybe it's not as scientifically advantageous to keep in the bag?
Exactly.
Or maybe you
So-
don't have any more of it?
Yeah, usually with touch fossils,
Yeah.
that's a great question. Usually with touch fossils, what you're looking for is something that's big and charismatic and durable. So like a Triceratops horn is a great example. But also it's usually something that's isolated. Maybe it was brought in by an amateur collector and they don't have good notes on where it came from. You might not have a lot of data associated with it.
Yeah.
Or it might just be an isolated bit that you do have data with, but it's not really scientifically important. So that is one of the things that might become a touch fossil like this.
So cool.
Yeah.
Really, really
Looking
cool.
fossils on display.
Exactly, Patchwork Pirate, yes. I wouldn't want to. This has been touched by a million people.
Lick.
Yeah. They've got some common questions right here. And kind of a illustration of how a dinosaur might become a fossil. Cool stuff. Here's a geologic map of Montana. I know I've shown a few geologic maps
And
on these
yeah,
broadcasts
very
before.
cool. Very cool.
So we are down here right
I
now
was about to ask.
in Bozeman, right there. And so Bozeman is mostly older rocks than dinosaur age. What is this color right here? This is probably, yeah, upper belt Missoula and bleaching groups maybe, yeah. But yeah, if we go, actually, yesterday when we drove up from Livingston, we went through some Mesozoic strata. There was a lot of like Jurassic age stuff and some Cretaceous age stuff along Bozeman Pass there on the way from Livingston. Yeah. This talks about what do dinosaurs fossils look like when you first discover them. Those are some particularly pretty examples. They often look much more chunked up than that. Yeah. Well, anyway, real or replica, I'll be talking about this and showing you how to tell the difference. Let's go ahead and get started with that. Let's go see some sauropod pieces right now. What's that?
Go ahead.
Okay. So, everybody loves sauropods until they have to dig them up because they get truly large. This is probably a Apatosaurus right here. Take a look at that. These are real fossil bones, by the way. Isn't that nuts?
Those are huge.
I mean, holy cow. So yeah, femur, tibia, fibula, astragalus, calcaneum, and then all of the metatarsals and phalanges and unguals. This is from like a full-size Apatosaurus, probably pretty close to full-grown. This is a rib, a single rib.
I see the white around it. Is that the cast?
So that
Jacket?
is, great question. It's similar to a jacket, because it's also made out of plaster, but we also put fiberglass in this. This is called a cradle. So when we bring a fossil back from the field and we want to keep it in collections or sometimes put it up on display, you make like a special cradle for it, and it helps keep it in place and preserve it, you know?
Okay.
So yeah. You can tell these are real fossils because A, they have all of these metal supports that are holding them in place, rather than like just, jamming metal rods through them. You don't want to do that with a real fossil bone. But also you can see the specimen numbers right there. So check that out. We've got a specimen number right there on the rib. Believe it or not, this is one of the smallest ribs on this animal ios.
Right, that's what this display says.
I know, right? I mean, yeah, take a look at that. This is from one of the ribs near the back of the rib cage. Yeah. Pretty cool. Likely 80 feet from head to tail. Probably weighed about 24 tons. 22,000 kilograms. Pretty awesome. Yeah. And then we'll take a look over here. So those are some really big individuals. Here's like a subadult or juvenile. And here is a really small individual. Not a hatchling. It would have hatched out a lot smaller than that. This would be an animal that's probably a few months old. Yeah, that is a replica right there, because you can see how the metal rods are just going straight through the bone. Yeah. Pretty cool, right? Just adorable. Adorable. Yeah. And there's a dorsal vert from a sauropod. Again, you can see the specimen number right there. See the cradle they made for it. It's the real fossil bone. Really awesome. Yeah. Pretty cool. Pretty cool. Let's see. Swap places with you real quick. So this talks about all the air sacs and hollows that run through the vertebrae. So just like birds, like you see right here, birds have air sacs and hollows that run through not just their whole like soft tissue structure, like all their guts and everything, but also through all of their bones. So when a bird breathes in, the oxygen, the air kind of fills its whole body. It's like this big pneumatized system. Sauropod dinosaurs, and other dinosaurs too, seem to have been the same way, which is really, really cool. So if you take like a CAT scan of this and look at the interior, you see it's all shot through with holes like this. So it would have been still really strong, but also really lightweight. One of the keys to this animal's success. Very cool. Where? Yeah. And Swiku asks, would dinosaurs have a lot of stretch marks from growing so fast? Probably not on their skin, but they kind of have, you can almost think of them as like stretch marks in the bones.
What would dinosaurs?
I asked a similar question about like,
Yeah.
would they have growing pains?
I don't know. Yeah,
Probably.
that's a really good question.
Yeah, or would they have
Yeah.
like evolved to not get growing pains because like
I don't know.
I don't know.
Yeah,
I'm just curious.
I think we should ask if birds do,
Yeah.
or crocodiles. Yeah, we'll use our EPBs,
Yeah.
our extant phylogenetic bracket. Do birds or crocodiles have growing pains? I don't know. I don't know if anybody knows. That's a great question. Yeah. Yeah. Growing up is hard. Yeah, Avatar, you're right. Yeah. How can you test for growing pains in animals? I don't know, Mayor Space. You can ask them. Here, let's go ahead and look at this display right here. So, this is an assemblage of juvenile sauropod bones. So this display is meant to show them as they were preserved. So like when they were found, they were in this position. So they're kind of in situ. It displays a group of young Diplodocus got their feet and legs stuck in the mud and died. This still happens to a lot of animals today. Like if you go out and talk to ranchers, they'll tell you about like calves, like juvenile cattle will get stuck in a mud pit and just kind of preserved there with their limbs kind of going straight down into the mud. And the same thing happened to dinosaurs sometimes. This is something that we seem to see again and again. Is like a bunch of juvenile dinosaurs all being preserved in the same place. Like a bunch of dinosaurs of the same species, of the same age cohort, all preserved in the same spot. So maybe it was just that like dinosaurs were really social, but they'd kind of segregate by size. Maybe you'd have like groups of teenage Diplodocus like walking around getting into trouble and loitering in a mud pit and getting stuck in it. Maybe this is what happened there. Or maybe it's that a whole herd was walking through and only the juveniles got stuck or something. It's really tough to say.
Yeah, that's what one of the placards hypothesizes.
Oh, really?
The
I don't think I've
adults
ever
are
actually
able to
read
get
this
away.
placard. But yeah.
My face while not reading placards. Dinosaur kids get stuck in anything. Avatar's so true.
Yeah.
Whippersnappers.
Yeah. Oh, and here's a quarry map that shows. This is the Mother's Day site quarry.
Yeah.
So each one of those is a different bone. And so when you're working a dinosaur site like this, it's really, really important to take good data. Draw your quarry maps, number everything. Make sure that you have everything recorded because those could be clues for figuring out, why did all these animals die in the same place?
I love that this placard calls out that the Mother's Day site was excavated for 3 summers by the Museum of the Rockies.
Yeah.
But now it's excavated by the University of Cincinnati.
Yeah,
I'm
yeah.
not sure if that's like here, now we've gotten the...
I don't know. MOR doesn't seem to do much field work anymore. So I don't know. I guess they handed off the site to somebody else. Maybe it was that there was a PhD student here who was working on it, or a master's student, and they moved to Cincinnati and kind of, they took the site with them. I'm not sure. Yeah. Yeah, pretty cool. Oh, and do you see that kind of like, it almost looks kind of squishy in there?
Yeah, it's almost like...
That is 2-part epoxy. So occasionally, that's the only thing that you can really use to get bits of fossil to stick together. We don't like to use epoxy that much because it's not reversible, but sometimes we have no other choice.
Are these bones just placed now in this display? They kind of look like they've been placed.
Well, I think these are supposed to be a facsimile of like how they looked when they were found.
So,
Yeah.
They
Yeah.
didn't like chunk up this.
Oh no, the matrix probably wouldn't look like this.
Right.
This has also been like smoothed out. Yeah. Yeah. This would be too big for a jacket, presumably. And these things would all be taken out and jacketed individually, I think. But yeah. Pretty neat. Big humerus here. Big humerus, got ribs, got caudal vertebrae. There's some chevrons for the underside of a vertebra right there. Really cool stuff. Pretty neat.
Can we take a second and just introduce ourselves to everybody?
Yeah,
'Cause
that's
they're
a great
not-
idea.
we can go over
Yeah.
the corner, right?
Yeah, let's introduce ourselves real quick. If anybody's new here, I'm Danny Anduza. I'm a dinosaur paleontologist. I used to work here. I dug up some of the dinosaurs. I'm going to show you.
I'm iios. I stream on the iios channel, and we're part of the stream. We're stream buddies.
Yeah,
We're stream buddies. So
yeah.
I'm so lucky to be here in Montana. with Danny and with Laurdee from the Laurdee Cooking with Laurdee channel.
Hi, I'm Laurdee. I run the Cooking with Laurdee channel. I'm here enjoying my time with iios and Danny. We are exploring Montana together, and Fossil, that you were asking about our road trip. iios is going to be going home Sunday, and then Danny and I will be continuing our road trip to explore some more museums.
It is going to be really, really cool.
Yeah.
So I hope you'll join us for the rest of this this adventure.
Yeah,
It's great to have you all.
So definitely give Laurdee and iios a follow if you haven't yet.
If you feel like it.
Yeah. Laurdee does mostly like gaming stuff. She's like, what did I say? iios does gaming stuff.
Get it right, Danny.
She is like incredible at video games.
I like what I do.
I don't know how she does it. And Laurdee is trained as a chef.
Yeah.
And she cooks some really awesome things. We might be doing some food streams here coming up.
We'll see.
Yeah.
Anyway, enjoy the stream. We'll be wandering around and chiming in and chat.
Yeah.
Yeah.
Let's take a look at Big Al over here before it gets crowded. So this is such an important specimen. Really, really famous. Big Al, MOR 693, I think is the specimen number. He used to be at Wyoming, the Wyoming Geological Museum. I don't know why he ended up here. But anyway, Big Al is a really famous animal. There's actually a whole documentary about him. You're probably familiar with Walking with Dinosaurs. Walking with Dinosaurs did kind of a spin-off. It was called Allosaurus, the Ballad of Big Al, a Walking with Dinosaurs special, and it's all about the life of this animal. Big Al is really, really special for a number of different reasons. He was really, really well preserved. This is his actual skull right here. Yeah. Amazing, right?
When this was excavated, were all the teeth individual, or are they all stuck in there?
This jaw and this skull were found together like this, so that's never been separated in 150 million years. Yeah. So it's amazing when we find a whole dinosaur skull in one piece like this. It's incredible.
One piece, but there are cracks in it that they fill?
Yeah, this is an
Yeah.
incredible specimen.
I know,
This is an
amazing, right?
incredible fossil specimen.
Just absolutely gorgeous.
Teeth, nasal cavities,
Uh-huh.
you can see definitely some repairs have been made.
Oh yeah,
in
certainly.
many places.
There's some epoxy. There's places where cracks have been filled in with water putty.
That's
I
really
mean,
fantastic.
this has lain in the ground for at least 145 million years. I don't know. I think Big Al is pretty old. I think he's Allosaurus germadzini, which would make him 150 million years old, something like that. Maybe even a little bit older.
It was CAT scanned to create
Yeah.
a meshwork of points to learn about tension and compression.
Uh-huh.
Interesting.
That's actually a different species of Allosaurus
Oh,
that they have right there. I think this is before we really understood that there were multiple different chrono species. That looks like Allosaurus atrox, maybe. Yeah. Take a look at that. Just absolutely
It's one
beautiful.
of the most beautiful specimens, really.
I mean, just gorgeous, right? And there's his nares, his nostril. There's the antorbital fenestra right there. It's basically a bunch of air sacs and stuff in there. Behind that is the orbit, the eye socket, and then the postorbital fenestra back there. You see those big crests on top of his head? Look, I don't know how well you can see right there, but look at those striations running up and down the crest, like little grooves. Those are probably attachment points for keratin. So those are blood vessel, nutrient grooves.
Feathers almost.
Probably
Crest.
keratin, almost like a fingernail structure, or like a bird's beak. Probably really brightly colored. Maybe it changed with the seasons or something. It'd be used as a signaling device.
Izzy wants to know if it's full grown.
No, Big Al was not full grown. Yeah. Despite being called Big Al, he's not actually that big. You can see him up there. But that's a cast. And this is the actual fossil. You're looking at the real, genuine skull of Big Al, and he's maybe 2/3 grown. Maybe I don't know. Maybe 60% grown. I don't actually know. I know that I think he's been sectioned histologically, so we can figure out how old he was. I just don't remember what it was, what the number came out to be. And there's a cast of an Allosaurus maxilla. So this is one of the jaw bones. This bone right here. And you can see the teeth in there. This has been kind of carved out so you can see the other teeth growing in. You're looking from the inside of the mouth out. So like, you could be sitting on the tongue looking out of the mouth right there, the upper jaw. You can see the other teeth kind of coming in, just like that. Isn't that cool? Really, really neat. So dinosaurs, unlike us, they constantly replaced all their teeth all the time.
Sweeku asks kind of a tough question.
Yeah.
On what scale is this incredible? Like 1 in 100 or 1,000?
Oh, for Big
Or
Al?
more?
Well, let me think. There's probably like, I'd say close to 100 Allosaurus specimens that have ever been dug up or are on display. Cleveland Lloyd has a bunch of them. Big Al might be the best preserved Allosaurus in the world. So, 1 in 100, 1 in 1,000, somewhere along.
Depends on what it's out of.
Yeah. Big Al is really, really special.
Yeah.
And
Special is a good way to put it.
I would really encourage anybody watching this, when you're done here, see if you can check out Walking with Dinosaurs' special on Big Al, Allosaurus, The Ballad of Big Al. It's really special, and it tells kind of the story of his life, and it's based on real fossil evidence here. It's actually based on these elements. So these are all different pathological elements of Big Al. So every single one of these, except for the foot down there, are the real fossils. These are the real specimens right there that you're looking at. These are all, they show evidence of injuries that he sustained in his life that later healed. So it's not like these are things that broke after he died. We find a lot of fossils that are, broken. Maybe the carcass got trampled after death, or maybe the pressure of the overlying rocks cracked them. But in this case, these were cracks and other injuries that occurred and then healed during his life, and there's evidence of healing there. So you see we've got a normal rib right there. Looks pretty normal. Check out this one, abnormal rib. That had broken and kind of gone off kilter a little bit.
Oh yeah, you can really see the crack.
So the one in the middle, right?
Oh, the one in the middle even.
Yeah, that's a normal rib right there.
Oh, right.
See that giant lump on it?
Yeah.
Yeah, that is all healed bone right there. That's a pathology. And there's another one right there with like it cracked, part of it got sheared off, and it's got a little spur right there. These would have been really painful injuries during his life, we think. And he survived all of these. It seems like he kind of got them. They don't necessarily seem like they all happened one by one. Oh, like all at once, I mean? Like they may have been like just one after another. And he survived all of these long enough for them to heal. Look at that metatarsal right there, all scrungy and busted up. His hand may have gotten torn at one point. So one of his phalanges is all infected. So each one of these that are kind of like healed abnormally like that, they were probably infected. And this is probably the injury that killed him right there. So look at that giant blob in the middle of his digit 3, his toe. So that would have been a really bad fracture, and it just did not heal properly. It just got massively inflamed. And these are bipedal animals, so if he can't walk or run properly, he's not going to be able to catch food. He still managed to survive long enough somehow for it to flare up like that to a crazy extent. But that's probably the injury that killed him. And there is the actual toe bone right there in the middle. So there's a normal one on the left and on the right side. That is the grievously injured one. So that's probably the injury that ended Big Al's life. If you'd like to see a dramatization of the life of Big Al, check out Allosaurus, The Ballad of Big Al. I remember showing that to my students when I did a summer science camp a couple years ago. And so we watched this, and some of them were really sad at the end, because it's not melodramatic, but it's very somber. You feel so bad for Big Al at the end. And
hard life.
Yeah. I have a cast that I made here at the museum back when I worked downstairs in the lab of Big Al's thumb claw. And so I pulled that out and unwrapped it and showed it to the class, and they just held it like it was a holy relic and passed it around. It was pretty magical. Yeah.
Peter Steve asks, would you ever be on a television production working on something related to real life dinosaurs?
I would love to do that. Yeah, absolutely. Yeah.
And as he says, so dinosaurs had arthritis?
Some of them certainly did, yeah. I mean, birds can get things similar to arthritis. I don't know if it's directly homologous to our arthritis that we can get, but yeah. We'll look at a few more displays right over here before we continue on into the Cretaceous period. We'll stay in the Jurassic for a minute here. Now check out these Stegosaurus elements. These are super neat. Here's some casts of Stegosaur tail spikes. Take a look at that. Is that larger than you would imagine?
They are big.
Yeah.
They look like they would hurt.
Yeah. And these are almost certainly a defensive weapon. So the plates on the back, I think, were for display. Yeah.
Plates are big too, honestly.
Wait,
This
is
is-
this its head?
This is its head right here.
It's
It's got a very small head. I mean, yeah, look at
Compared
the
to the plates,
look at the
it's
skeletal
got a
diagram back there.
butt.
Yeah. It does, yeah. Stegosaurus is so cool. And yeah, you can see those grooves in the plate right there. These would be nutrient grooves to supply the keratin that would have coated the plate. Probably been very, very brightly colored. Yeah, Stegosaurus would have been, as I've said before, a very flamboyant animal. Very, very showy.
But Dundee, I think the bones, it's not even that the bones swell up when they break, it's that the body creates more bone around the break
Yeah.
for protection.
Kind of in the way that, like, I don't know, if you break your arm or your leg, your doctor would put a cast on it to help keep everything in place so that when it heals, it doesn't heal all crazy like that. It doesn't have all this bone flaring out. Big Al did not have a doctor when he died. And so, yeah, his bones did not heal properly. Didn't heal nice and beautifully like ours do nowadays with medical care.
Didn't Stegosaurus have like 2 brains?
That is a great question, yeah. Stegosaurus does have what we call like an enlarged sacral plexus. So there's there's a spot in its hips. You can kind of see it in the, well, not really, in the skeletal diagram. Look at its back legs there. Got those big, thick vertebrae. So as the vertebral column goes through the hips, the vertebral centra get really big. So like the body of the vertebra. And so there was a hypothesis a long time ago
It's
that
a butt brain?
yeah, that maybe Stegosaurus, since it had such a small brain in its head, and here's its skull right here, its brain is like about the size of like I was going to say a big golf ball, but golf balls are pretty standardized in size, aren't they? Anyway, there's a hypothesis that maybe this like enlargement in its spinal cord and its hips was like a second brain. I think it's an idea that needs some more exploration. I mean, we still don't really understand how bird nervous systems work, like, as much as I would like to. Maybe Stegosaurus actually has something interesting going on there between its hip bones, but I don't know. Something that requires more study.
What size were the young baby Stegosaurus when they hatched?
Oh, very small. So all dinosaurs, when they hatched out, they were very small. Like, the animal would be... They hatched out of an egg smaller than like a volleyball. All dinosaurs. There's not really any bigger you could make an egg. Maybe a football or a soccer ball. But they would have been really small when they hatched out. Like all dinosaurs, they had to grow pretty quickly in order to survive. Yeah. Got all of these cool... This is just like a sample platter of different Jurassic fossils from Montana. You've got some fossil fishes in here. We've got some invertebrates like beetle larvae, unidentified flying insect, and then all of these cool, yeah, again, like a sample platter of, you open up the box and there's just like, oh yeah, there's all these cool little things from the Jurassic. There's a Camarasaurus skull up there. That's smaller than the one I have in my office. Very cool. And then, check this out. This is the Livingston sauropod. So there's a number of sauropods from this quarry. I don't think they knew that when they made this display. But I helped set up camp here a couple times. We drove through Livingston yesterday. This is one of the dinosaurs from there. These are some verts. It's a caudal vert. And cervical vert right there. Or no, maybe that's a dorsal? It's a weird looking dorsal. It's all crushed. Okay, yeah. But yeah, so it's got the bifurcation at the top. Sauropods do all kinds of crazy weird things with their vertebrae. So in this case, rather than just having like a single neural spine in the middle, it bifurcates into two. This would have something to do with like all of the ligaments that help support the animal's neck and tail as it walks around. Sauropod vertebrae are just crazy weird, and not only do they change really quickly, as the animals are evolving, but they also change through ontogeny too. There's a lot of variables there when you're looking at sauropod vertebrae. It gets very complicated very fast. So it's
pieces of this sauropod is actually up above us.
yeah.
It says.
Yeah.
Oh.
There it is up there. So it's the diplodocid.
It's got kind of a small head.
Yeah. Well, that's
But I mean, I
that's
guess
by
it
design.
can't be that huge. 'Cause
Exactly.
otherwise it
Too
would-
heavy.
It's at the end of a really long neck, yeah.
It's evolutionary disadvantageous to become smarter.
Well, it really was, yeah. I mean, if you've
Well,
got
assuming bigger brain size means smarter.
if you've got a 15-foot neck, it behooves you to have a small head and a small brain. Just because that would be too much to carry around, otherwise it just wouldn't work. And so these guys were remarkably successful. The first of the big sauropodomorphs show up in the early Jurassic, so 190 million years ago, and they go all the way until the end of the Cretaceous, 66 million years ago. So 190 minus 66, what's that?
123, 24.
124 million years these guys were around. Really, really impressive. Thank you, iios.
Yeah. Hanny's Vorceps says you're the best docent ever.
Thank you, Hannies. That's funny. I just saw a second ago Lee Hall walk by, somebody I used to do field work with. He looked like he was busy, so I didn't want to bother him. But we'll see if maybe we might get lucky and catch him in a bit. Yeah. Oh, so you already saw Deinonychus. Well, let's go ahead and talk about Deinonychus then. So I've talked about Deinonychus a lot on my channel before. If somebody types in ! rotating skull, I have a MooBot command for that. This is the Velociraptor from Jurassic Park, and it was hugely important when it was first found.
Hi, Austin.
It kind of helped spark what's been called the dinosaur renaissance. So, before the discovery of Deinonychus, most paleontologists and members of the public, when they think about dinosaurs, they think about them being just kind of overgrown reptiles, with all of the things that kind of come along with being a reptile, like being scaly, being mostly ectothermic, cold-blooded, not being particularly bright, intelligent or social or dynamic in your daily habits, not eating a lot of food or living in groups or anything like that. But then, this dinosaur was discovered back in 1969 by, I don't know if it was discovered by John Ostrom, but he was famous for digging it up and studying it. And here was an animal, just like the velociraptors of Jurassic Park, that was kind of small, seemed really kind of lithe, very athletic, probably would have been really fast-moving, seems to have had a large brain. A lot of these features imply warm-bloodedness, maybe sociality. Several of these were found in a group, which kind of implies that maybe they lived in groups too. And,
Austin was saying it took him a while to recognize me. Yeah, the hat, it's a different look, and I'm not, it's a different, I'm not on my green screen like I usually am. I'm out here in the real world.
Wow. Here at Museum of the Rockies, yeah.
Yeah.
And here's some of these really cool elements. One of the important things is that the tail has this basket of ligaments that run down it like this. Right here. Just like you have in a hadrosaur right here. These are ossified tendons. So these are actually tendons that turn to bone over the course of the animal's life. And so these stiffen the tail. And Deinonychus had an incredibly stiff tail, probably like a broomstick out behind it. So this is not an animal that dragged its tail. It used its tail for balance as it walked and ran. I don't know, hugely important dinosaur. It's Deinonychus really changed the way that we thought about dinosaurs. I say we, I hadn't been born yet, but that's the paleontological we. And we've got another nice little sampler box of different fossils from the Cloverleaf and Kootenai formations, early Cretaceous of Montana. Got an armor plate from an ankylosaur, Sauropelta. It's one of the cooler armor plates. It's got this big spike on it.
Yesterday I pronounced it Kootenai, but Kootenai does have a bit of a better ring to it.
Tomato, potato, yeah. Tenontosaurus lower jaw. We're going to see a Tenontosaurus behind us. Got a plastron. This is the chest plate of a turtle. That's a piece of it right there. Sauropod tooth, lungfish tooth. You can find lungfish just like lived in the Cretaceous, still around today. Places like Africa and Australia. Yeah. So I love that there are these displays here because, again, this is a very Montana-centric museum and a lot of people from around the state come here. And for them to be able to see fossils from the area where they live is really kind of magical. It helps people make a connection. where they otherwise, I don't know, otherwise it's a museum display, but when you see something from near where you live, it really hits home. And this also just goes to show that the context that these fossils are found in is just as important as the fossils themselves. If you don't have good data on them, if you don't have a good sense for the other animals that lived in the environment, you'll have a really incomplete picture.
Plastron is French/Flemish word for necktie.
Is that so?
Plastron equals turtle necktie. Very
It's,
interesting.
yeah. Yeah, turtles have two big major parts to their shell. There's the plastron and the carapace. The carapace is the round part on top. The plastron is the flat part underneath. So, yeah. But part of it does extend up to the neck right there. So I wonder if it's the same root word or something like that. Very cool. All right. And I know on my channel we've talked a good deal about Tenontosaurus before. Here is another very tragic Tenontosaurus.
This is amazing.
These are the real bones right here. Yeah. So let's see if I can extend
Incredible
this a little
fossil,
bit.
really.
Isn't it gorgeous? Yeah.
Is this the cast it was in, or this is?
This is a cradle that was
This is
built
the
for it.
cradle.
Yeah.
Okay.
Yeah. Our plaster jackets are much thinner and they look scrunchier than that.
Yeah.
This is made for display. Yeah. But yeah. We got a lovely Tenontosaurus right here from the Cloverleaf Formation of Montana. And I've talked before about how anytime you see Tenontosaurus in popular media or in dinosaur illustrations, paintings, books, that kind of thing, Tenontosaurus never gets to just be its own animal and do its own thing. The focus is never on Tenontosaurus itself. It's always being torn apart by a pack of Deinonychus. And that is because we actually have evidence of predation, or at least feeding, from Deinonychus on Tenontosaurus. You see these dromaeosaur teeth around there? Those are Deinonychus teeth all around the animal. There's one right there.
Lucy wants to know if that's the natural color of the bones.
That is the natural color of the bones, yeah. Different fossil bones from different formations will have different colors. A lot of this is based on minerals in the groundwater and minerals in the surrounding rock. But from the Cloverleaf, they're usually kind of a dark brown like this. They might get a little darker when we put consolidants on them, like Vinac, like the glues that are used to help preserve the fossils. But yeah. Justice for Tenontosaurus. Yeah. So yeah, Tenontosaurus. It's famous for being the prey of Deinonychus. It doesn't really get to be its own animal. I don't know. People love Tenontosaurus because it gets eaten by Deinonychus, and this is one of those instances. Yeah. And then right here we have an example of that. This is Tenontosaurus and Deinonychus. I've talked about this display before on my channel. It's really cool to be able to show you in person. So this is kind of cool because it goes from skeleton to all fleshed out. Pretty neat, huh? So this is part of the big renovation here at the Siebel Dinosaur Complex around 2006. This is a new display at the time. It is already grievously out of date. That's not a bad thing, necessarily. It's out of date because of research done here at this museum, which is really, really cool. So, at the time, this was cutting edge. You've got feathers on your dromaeosaur right there. These dinosaurs are very brightly colored. We think that that's true to this day. But it turns out there are a number of things that really ought to be changed about this. I see right here it's using its claws to kind of almost kind of slash at the Tenontosaurus. That is now no longer really what we think. And also the feathers. See how there's just kind of a fringe of feathers over the top of the animal? In the time since this display was created, we now have evidence that these guys were just fully coated with feathers. This would have looked like just a big old weird ground-running bird. And that evidence comes from dinosaurs like Velociraptor. So Velociraptor has these cool quill knobs on its ulnae. This was discovered around 2005, or published on it. then at least. So this animal should be fully covered with feathers nowadays, and it should have like big old flight feathers coming off of its arms.
It's funny, these feathers feel so long. They almost feel like a shag.
Yeah,
Carpet a little
yeah.
bit, yeah.
But I mean, the feathers would have been much more functional in the actual animal.
Yeah.
And so you might ask yourself, like, this is a great big animal. Well, I don't know, it's bigger than most birds today. Why would it need flight feathers on its arms? And I would say that's a very good question. This animal's clearly too heavy to fly. So what's it doing with wings, basically? And Denver Fowler.
Weasel asked, yeah, what's the purpose of them having feathers if they didn't fly, right?
Exactly, yeah. A lot of dinosaurs had feathers. Feathers are good for things other than flight. They can help insulate. They can be used for display, stuff like that.
Like penguins have feathers.
Oh, yeah.
Yes.
Penguins have feathers. It helps them retain their body heat. And also helps them cut through the water really quickly. Provides a nice smooth surface. But having, like, wings with flight feathers on them, why would a ground-running animal that can't fly need flight feathers? And that's been an intriguing question. I think the answer came in 2011 when Denver Fowler and Liz Friedman Fowler and a few other authors published a paper with a new hypothesis for how these animals would have caught their prey.
Is raptor mostly a misnomer applied to dinosaurs these days?
Not applied to birds of prey.
Well, but that makes sense. That's fair.
Yeah.
Yeah.
No, I'm being snarky. But yeah. When paleontologists talk about these animals, we call them dromaeosaurs. Nobody called them raptors until Jurassic Park. Yeah. Anyway, so why would these guys need flight feathers and wings if they couldn't fly? I think that question was, I don't know, a really good hypothesis to explain it. Was published in 2011. On the Predatory Ecology of Deinonychus was the title of the paper. And the idea is that these guys would have used their claws, especially those big digit 2 claws, that sickle claw right there, these guys are famous for. They would have used that a lot like modern birds of prey do. So if you have like a big golden eagle or a hawk or something and it catches a prey item that's too large or too heavy to fly away with, they have like a strategy for that. They'll take that big digit 2 claw, because they have it too, it's just a little small. They'll sink that into the back of their prey. Picture like a jackrabbit or something. The golden eagle swoops down, grabs a jackrabbit, and the jackrabbit's too heavy to fly away with. They'll sink those claws into it, and as the jackrabbit is like struggling and moving around and trying to buck it off like a bucking bronco, they've got the claws sunk in, and they will flap their wings in order to stay upright on top of it. This is a behavior that we observe today in modern birds of prey, and that's why they have those hypertrophy digit 2 claws, it seems. And this also makes a lot of sense for dromaeosaurs as well. It explains why they would have wings, despite not being able to fly, and why they would have those hypertrophy digit 2 claws.
Japasaur says feathers in more primitive birds, has a theory, such as ostriches are used to scare off bigger predators to make them look bigger and badder.
Yeah, again, display. Display can come in many, many shapes and sizes. So, pretty cool. Anyway, so I think it's really neat that this museum display, which was cutting edge at the time, has been rendered completely outmoded by research done here at this museum. That's the way science should work, Just really, really cool. So I was excited to share that story with you. We will, let's take a look at, we were talking about dinosaur eggs a minute ago. I'll show you some dinosaur eggs. Here's L.J. Krumenacher. He used to come to some of our DLS meetings. He's another paleontologist from Idaho. And, here's some cool plant fossils from his study area, in the Blackleaf Formation in Idaho.
Just kind of another question. Someone asked, do dinosaurs have multiple sets of teeth?
Oh, yeah. We talked about that earlier. Yeah, so dinosaurs constantly replaced their teeth throughout their lives. They never ran out.
Okay.
Most animals are like that. Most animals that have teeth. Mammals, like us, are the weird ones. We only have 2 sets of teeth throughout our lives. Certain mammals have more, but yeah. All right, let's look at some of these giant mystery eggs. There's Jade. Jade is doing her PhD up in Toronto, but she's collecting some of these. I've done some field work and other stuff with her before. Here's Macro elongatulithus. This is a cast. of one of these giant eggs.
Really see the egg texture.
I know,
on
really
the
cool,
real
huh?
ones. It's really cool.
Yeah. So those are some real eggshell fragments right there. And these are models of what the eggs would look like intact. This is about as big as dinosaur eggs get. And I'll try and hold this to give you a sense of scale. They're about, what would you say, like 15 inches long? Something like that?
Yeah.
Yeah.
That's what I would say.
This is about as long as dinosaur eggs can get. You can make them long and skinny, or you can make them like, spherical. The biggest dinosaur eggs by volume are probably spherical. They're about the size of like a volleyball or a soccer ball or a football, if you're not from the U.S. Yeah. But this is about as long as they can get. There's only, this is about the maximum size that you can actually make an egg on land before it collapses under its own weight.
Darkness was, this is on feathers again. Darkness was wondering if it is thought the dinosaur feathers are more like down feathers, like fluffy.
Some of them were. We've got a lot of different examples of dinosaur feathers. Some of them are what we call proto feathers, where they basically look like hair. They're just simple filaments. Some of them are kind of like down, like really fuzzy looking. And some of them are like flight feathers, where they've got, that vein in the middle with all the stuff coming off of the sides, all those branches with the interlocking barbules. So some dinosaurs had like full-on complicated flight feathers, including those guys, the dromaeosaurs, like
Tropical
Deinonychus.
wonders why chicken eggs are more round, and these are conical.
Yeah, well, these are more like, I don't know, they're elongate like this. Yeah, and we don't really have a good understanding of why different dinosaurs have different egg shapes yet. Or different birds, too. A lot of birds have, well, I don't know. Bird eggs don't vary in shape as much as dinosaur eggs do. But yeah. I know the biggest dinosaurs, like the sauropods, had spherical eggs. Maybe just because they're bulkier and kind of gives you more space as an embryo.
I'm pretty sure you can do x-rays on eggs.
Oh, yeah.
Is he asks.
Yeah. CT scans on eggs, yeah.
Were they leathery or shelly?
Different dinosaurs had different egg textures, yeah. We only discovered this last summer, by the way. Before, everybody assumed that most, if not all, dinosaur eggs had hard shells like this. So these are hard shells right here. There are a few dinosaur groups, like the ankylosaurs and the ceratopsians, that we'd never found eggs from before. And the question was did these guys even lay eggs? But it was just published on last summer. There were a few examples of ceratopsian eggs that were found. It seemed to show kind of a leathery texture. They had soft-shelled eggs. That's probably why they'd never been found before. It's just soft-shelled eggs are more difficult to fossilize. So yeah, great question. But this is a giant oviraptorosaur. This is probably the kind of animal that laid these eggs, I think. Pretty neat. You would probably be about this tall compared to this animal. It's a big critter. See those really cool feathers on it? Again, not simple feathers, but complicated branching feathers with a vein and everything else.
Izzy does request that we try to be aware of the lights behind us because it makes it hard to read our lips.
Okay, yeah.
I told her.
We'll try to do that, Izzy, yeah. This is really cool. It's very rare that you'll see this in any dinosaur museums anywhere. We've got a cast of its Nontosaurus skull. Right here. Here it is, with all the pieces together. A skull is made up of many, many bones. And this is what that looks like, kind of exploded a little bit so that you can see the individual bones. There's a lot going on there. Nice, do you mind?
Not at all.
All right. Texture. There's lots and lots of different components, and they all fit together in different ways. We've got lacrimals, frontals, nasals, premaxillae, maxillae. This guy's got a really special bone that only these beaky dinosaurs have. This one here at the front of the jaw, the lower jaw, is called the predentary, and only ornithischian dinosaurs have that, only the bird-hipped dinosaurs. I don't think there's any other animal that have a predentary bone like that. It's like a beak bone at the front of the jaw.
Izzy wonders, how can you tell if a piece of the fossil is part of the skull or not?
Well, the skull is a thing unto itself, you know? Its skull bones look very distinctive. They're usually very kind of small and thin, as you can see here. So, when you're in the field and you find a bone that might be a skull bone, it's usually know it's from the skull. It doesn't look like a vertebral piece. It doesn't look like a limb bone or a rib or anything. Skull bones, they're very complex looking. As you can see here, lots of different stuff going on in these skull bones. And usually we find dinosaur skulls disarticulated, kind of in pieces like that. Yeah. Oh, we were talking about the dinosaur bird link when we were talking about Deinonychus a few minutes ago. This display is all about that. Dinosaurs are the ancestors of birds. Let's get some birds are dinosaurs emotes going here in the chat. But here's just a few little anatomical examples of that. Right here we've got that's a chicken skeleton right there. Very cool. And it's got all those interesting birdy features like a wishbone, three-toed feet. It's got those semilunate carpal bones that allow the wrists to go down like that. And here we have examples of these from dinosaur skeletons too. There's a Deinonychus semilunate carpal, one of the wrist bones. So Deinonychus, the raptors from Jurassic Park, held their wrists in the same way that chickens do. And we've got a furcula or a wishbone of Bambiraptor. This is a little dromaeosaur from the Cretaceous of Montana. And that bigger one right there is a Tyrannosaurus wishbone. That is a real T-Rex wishbone that you're looking at. Isn't that cool? Very, very neat. So yeah. Super cool. Let's see. Would it work to phrase skulls as being more organizational rather than structural or load-bearing? Austin, that's a good question. I guess so. The skull is like... Anytime that we find a dinosaur skeleton, if we find a skull, we are extremely happy. The skull is the part of the animal that gives you the most information because it has the most clues about the animal's biology. Think about it. The skull, the head is where all the sensory stuff is located. So, you've got the eyes in there, you've got the mouth, you've got the nose, you've got the brain, you've got the teeth, all centered right there in the skull. It's like the most important part of the animal. And so, if you can find a skull, you can learn a great deal about whatever animal you're looking at.
Danny?
Yeah.
Avers has an interesting question.
Yeah?
They're wondering if there's a way to differentiate rock fractures from being falling rocks or rocks used as a weapon. Is there any way of seeing if dinosaurs took down prey with rocks?
That's a great question, and it's difficult to imagine. I don't know how you'd go about testing that. Yeah. That's the thing. Science is all about testing. Like, you've got to figure out if there's a way to falsify your hypotheses.
The world's first armored tank, you might say. That trunk is completely covered with thin, bony plates.
Wouldn't make any different kind of crack or anything like that, so I don't think so.
This middle one?
Yeah, okay. Yeah, it's fine. Anyway, we've got Deinonychus and Tenontosaurus behind us again. The skeleton's right here. I just want to give you a nice view of that. Pretty cool, right? And then poor Tenontosaurus is... just can't catch a break. And I'll show you another display in just a second. Kind of emphasizing that. But, yeah, it's right over here. So, take a look at that. So we've got a Tenontosaurus skull right there. Which is incredible, right? It's just beautiful. This is all in articulation. And look at that curve to the neck right there. There's a pose that we often find dinosaur skeletons in. It's called the epistotonic posture. And so it's kind of your classic death pose for a dinosaur. It's like the head is kind of thrown back, the neck is really sharply curved. And for a long time, this has been explained as like rigor mortis, like as the body decays, maybe the ligaments in the back of the neck kind of just shrink like that, and they pull the head toward the back. But there's another hypothesis that's actually put forward in that paper, by Foe and Kevin Padian, The epistotonic posture of vertebrate skeletons, post-mortem contractions, or death throes, ? So the idea is maybe this is actually something that occurred as the animal was dying. With warm-blooded animals that have a very active metabolism, and their brains require a lot of oxygen, maybe as the animal is dying, that's just kind of like a pose that they undertake as oxygen is being cut off. So that could be the case for dinosaurs like this. I haven't read that paper, but I should check it out, because there's another hypothesis that I don't hear explored enough. I remember when I was up in Great Falls, Montana, I was visiting with a friend. I was staying with him there, and we were riding our bikes along the Missouri River. And saw this big, like, weird white thing floating in the water. And I go, "What is that?" And we go over a little bit closer. It looked like a big shopping bag or something at first, but it was too big. It was weirdly shaped. It was a dead goat that had been, like, just floating there in the water. And as it's drifting along with the current, all of the loose bits, like the parts that can move, like the limbs and the head, are all kind of just like trailing behind it like that, as its body is being pulled down this river. And so it makes me wonder if this pose might have something to do with that, with like fluvial transport. That's just kind of a dangly bit of the animal, and maybe as current is dragging it along, maybe those parts just, are kind of trailing backward. So I don't know. Yeah. It would be
out for sure.
Yeah, complicated. Like, I don't know. You would need some pretty in-depth taphonomic analysis to try and test that. Yeah. All right. Should we take a look at some of these swimmy critters? All right. Here we've got a display with some Mesozoic marine reptiles. So these are animals that lived at the same time as the dinosaurs, right here in North America. As we've talked about before, there's this big, beautiful interior seaway that once ran through right through the middle of the country. It was like a shallow tropical sea, and all of these weird and wonderful creatures lived there at the time. Yeah. You need some? Okay. So you probably know, like, these parts of the country are really rich in, like, natural gas and oil. A lot of that is from the WIS, the Western Interior Seaway. All of these microscopic microorganisms, microscopic organisms in the water column, things like plankton and krill and stuff like that, they would die and then they'd drift down to the bottom. And over time, you just get billions and billions of them in these layers that just get compacted. That eventually turns into oil when all of their carbon just gets compressed. So that's where fossil fuels like that come from. Oil and natural gas. Coal comes from plants.
Fluvial transport. It's such a fun word. It is, Raven.
Yeah.
It is.
Yeah, or you could say river transport, but fluvial, I don't know. There's a poetry to it that I really like. Anyway, let's look at some of these critters. Back there, does anybody in chat have a guess what this is? What does that look like to you?
Looks almost crocodilian, slightly.
Does it now? Mm-hmm. You are right on the money.
Yeah. Hell yeah.
Yeah.
Smart.
So this critter's been named Terminoneris. This is not just crocodile-like. This is a crocodile that evolved for life in the oceans. So it's got that long crocodile-y snout. That's probably what you were looking at. That and maybe like the back, right? Those armor plates on the back? Mm-hmm. Yeah. So I think this actually happens a couple times during the Mesozoic. Crocodiles take to the sea, and they become much more streamlined. Their limbs kind of become flippers. Their tail sometimes develops like kind of a fishy fluke at the end. And they end up looking like like this Wikimedia Commons illustration. But yeah. It's a really long snouted crocodilian. It's probably would use its jaws to... Yeah, I know, right? Man, they could have paid a graduate student $5 to make an illustration, but they didn't. Anyway, yeah. So yeah, very, very cool animal. It's from right here in Montana. Yeah, from Carbon County, right down there. So called Carbon County, probably because there was a lot of oil or coal or natural gas from that county from the same Western Interior Seaway that gave us this animal. And then we've also got some...
We didn't come here to fight with monsters. We came here to find fossils.
Cool. So, yeah. I forget, is this guy the Paleontologizing? Yeah, this is the Paleontologizing right here. So this model that you see up here is based on this animal. Paleontologids are these plesiosaurs that they're kind of penguin-like. They've got big round bodies, kind of short-ish necks. They were probably like active pursuit predators. They probably moved really, really quickly through the water. So penguins will swim by kind of like flapping their wings on the water. These guys, if you think of them the same way, it's almost like they have two sets of wings. They're like double-winged swimmers. So they'd probably kind of move their flippers, like the front ones up at the same time the back ones are coming down, and they'd kind of go back and forth like that. It would also make them really maneuverable in the water. So imagine this just being like a giant, super fast penguin, chasing after fish and squid and stuff like that. Really cool. Yeah. And then over here, let's see. Oh yeah, we also have elasmosaurs. I think, is this guy an elasmosaur? Anyway.
It is identified as an elasmosaur, a plesiosaur.
Let's see. A and B. Left specimen, right specimen. Do those correspond to A or B? Because this also looks like a Paleontologid to me. This doesn't look like an elasmosaur.
Yeah, actually, Paleontologid is actually exactly what it says it is. Paleontolidae.
Right specimen.
Indeterminate, yeah.
Yeah, that's this one here, like I said. So that's not an elasmosaur. That one also is not an elasmosaur, right?
Well, it says it's a plesiosaur, Edgarosaurus.
Edgarosaurus. I don't know if Edgarosaurus is... Yeah, I'm not sure. Anyway, yeah, I just wanted to share with the... well, here we've got an illustration of one, a long-necked plesiosaur right here. Not a great illustration, but we'll run with it. These guys have really long necks. So these guys have vertebral counts on their neck up to like the 70s. I think the record is like 75 for a number of vertebrae in the neck. We, by contrast, only have 7 vertebrae in our necks, 7 cervical vertebrae. Does anybody have a guess as to how many vertebrae a giraffe has in its neck? Do you have a guess?
7!
It is 7, yeah.
We've done this before.
We've done this before? Okay. Yeah.
I had to pause to give Chad a second to think about it. Yeah.
But yeah. Yeah, giraffes also only have 7. All mammals, except for there's like 3 exceptions. All mammals have 7 vertebrae in their necks. And there's something really interesting about like the mammal bow plan, where mammals don't seem to be able to have more than 7 vertebrae, more or fewer, without it just messing everything up in their genetic code. It's like that's kind of intertwined with something else. It's like occasionally there will be animals that have mutations with like, different numbers of vertebrae, and usually they get cancer and they die really, really quickly. But reptiles don't have that problem. They're like, we want longer necks? Yeah, just throw in a few dozen extra vertebrae there. That's how plesiosaurs did it.
If it were possible, what type of dinosaur would be best suited / able to survive in today's world?
Mabonesy, that's a great question. I could answer it in a number of different ways, really. We're back. Thank you, everybody, for your patience during that. Sorry. Some equipment difficulties. But I hope we resolved them. Yeah.
5 by 5. Yep.
Okay.
Perfect. All right. Awesome.
Still here.
Thank you.
Yes.
We should introduce ourselves again real quick, because it's been a while.
Absolutely.
Yeah.
I'll just say really quickly, I'm iios. I stream games. We all stream together a bunch of the time. It's so good to see you.
I'm Laurdee. I host the Cooking with Laurdee channel. I do cooking content and food content, and I hang out with my friends iios and Danny.
Yeah. I'm Danny Anduza. I'm a dinosaur paleontologist. I do science outreach here on Twitch, and today we are visiting my old Museum of the Rockies in Bozeman, Montana. And in a little bit, I'll show you some of the dinosaurs that I helped excavate. But for right now, we're just doing a tour of the Seabull Dinosaur Complex here. Really cool dinosaur hall. Honestly, one of the best dinosaur museums in the world. So I'm so excited to share it with you.
I'm interested in your island. It's got nothing to do with oil. I'm a paleontologist.
Well, you're not even a good liar.
This is such a cool dinosaur story right here. This is one of the newer displays here at Museum of the Rockies. This is Oryctodromeus up here. And we're going to go around this way. Isn't that cool? Yeah. So this dinosaur is the first dinosaur to be named from Idaho, which is a big deal. Idaho is not well known for its dinosaurs. What is Idaho well known for?
Potatoes.
Potatoes. Where do potatoes grow?
Idaho.
Well, where do they grow?
Oh, in the ground. What are you asking?
Oryctodromeus also grew in the ground. This is the first known burrowing dinosaur. First known non-avian burrowing dinosaur, I should say. But this is research that was conducted right here at Museum of the Rockies and at Montana State University. Really, really cool stuff. But yeah, this is a small ornithopod dinosaur. It's a little beaky,
You're not doing so
plant-eating,
badly
two-legged
yourself for a
dinosaur.
paleontologist.
We used to maybe call like a hypsilophodontid. That name has fallen out of favor. But yeah, so through really, really careful taphonomic work by Dave Verricchio and Yoshi Katsura and Eric Mortschauser, they were able to determine that this dinosaur actually lived in a burrow, or at least reared its young in a burrow. This is really fortuitous that Dave was one of the guys working on this. This is my undergraduate advisor. Dave Verricchio works on taphonomy. So taphonomy are like, those are all the processes that are involved when, like, after an animal, between when an animal dies and when it's discovered. So like, you know, the skeleton falling apart, being scavenged, you know, burial, all that sort of thing. It requires really, really careful study to be able to gather data about this kind of thing. And so almost anybody else digging this up probably would not have made the same discoveries that Dave did. So we're really, really lucky that he was the guy working on this. So this animal was found
They found some of those kinds of dinosaurs up in
basically
Antarctica.
in a big lump like this.
Similar.
Right there. And, yeah. So skeletons partially articulated. So they, like, clearly were not transported after death. They were buried where they were, kind of in a big lump like that. There was an adult and 2 juveniles, if I remember correctly. And by very, very careful digging and recording the lithology the entire way, they're able to determine that the rock in here is different from all the surrounding rock. Basically like this big weird slug of different sediment right there, with the bones lying in the bottom of it. This was an ancient burrow. And, you know, it's easy to say something like that, but in the sciences you have to test it too. And so, you know, occasionally we'll run experiments in paleontology, and here's my friend Kerry Woodruff. Back when he was, I think, a master's student, or maybe he was an undergrad at the time. But he is testing this hypothesis by taking some rabbit bones, arranging them like this in the bottom of this contraption, and then pouring a bunch of mud into it and seeing the way that they disarticulate, or, you know, seeing if the patterns kind of match what we have here in the burrow. And indeed, they did. These are really cool publications. You should take a look at them. Right here. But yeah, this is really awesome science. And it just goes to show that there are so many things about dinosaurs still left to be discovered. I mean, for a long time it was argued that, like, you know, dinosaurs, you know, they lived on land and they didn't live in the oceans. They also didn't burrow or anything like that, you know. They're fairly conservative in their modes of life and that kind of thing. No. There are probably other dinosaurs other than Oryctodromeus that could burrow as well. But yeah, some of that research might be forthcoming. Not going to talk about it yet. But yeah, Oryctodromeus, our first burrowing dinosaur. Really cool. So there's mom or maybe dad and 2 little ones right there. Those big yellow eyes. Very cool. Very, very cool. These animals have a number of skeletal adaptations that seem to be consistent with burrowing behavior. They've got a big old olecranon process on their ulna. Seems to be a muscle attachment point. just like you have on other burrowing animals like armadillos. And their snout may have actually been used for digging as well as their forelimbs and their hind limbs. And they've got these big old beefy scapulae, big old beefy shoulder blades. And I'll show you that in just a second. But yeah, really cool. Take a look at that. There's a cast with this animal's forelimb. That big old scapula, really robust. And there's one for an armadillo right there. And there's the olecranon process. An armadillo has a huge one. It's kind of, I guess you could call that like your funny bone. These guys also have a big olecranon process. The back of the ulna. Pretty neat. So yeah, with that we're going to move into the Mesozoic Media Center. This looks way different from what I remember. This all just used to be empty back when I was here working at MOR.
Empty?
This was empty back here.
Like a museum, like a meeting room?
This part right here? No, it's just,
It just
you'd
was
walk
empty.
through it and it was just an empty corridor. There are a couple of video monitors, but they almost never worked.
Oh, what a time and oh, what fun. Playing tag with the Rick Warner.
I truly enjoy the content of your
This is
streams.
the real fossil bone
Keep
right
up
there.
the awesome work.
And they've opted to make a black cradle.
I was going to ask about that, yeah.
Mm-hmm. So the way that this works, the way that you make a cradle, you can see some white under there too. But you, in order to make this cradle, you would turn the skull over so the bottom is exposed. And then you take some sheets of fiberglass and you soak them in plaster of Paris. And you set those to the side. You take like a plastic bag, like a sheet, you drape it over the fossil so you don't get any of the gunk on the fossil. And then you start draping the fiberglass soaked in plaster of Paris over the top. And you put enough layers on there that when it hardens, it's got enough material there that it'll help support it. So, no, Yoshi's Trike is forthcoming. Yoshi's Trike is going to be toward the end in the Hall of Horns and Teeth. So stay tuned for that. Yeah. Yeah. Right there. Yeah, Ineosaurus. This is one of these dinosaurs where I think the holotype is here at Museum of the Rockies. So like the original specimen of Ineosaurus is right here within this edifice, which is really cool. And you're looking at kind of a squashed skull. So this is the left side of its face right there. There's the eye socket. Here's the nares, the nostril down here. It's been kind of compressed by overlying rocks. Yeah. And yeah, look at those big fenestrae in the back of the frill. These big hollow openings and those big spikes coming off of the parietals. Very cool. Very, very cool. This is new. I've not seen this on display yet. They must have put this up in the last 3 years, but it's very cool to see. Yeah. Here we've got a little video display showing, I think these are the practiced hands of Carrie Ansell, prepping out some dinosaur fossils right there using an air scribe. So it's like a tiny pneumatic drill. And it's painstaking work, but she was maybe the best person in the world at doing this. Carrie Ansell, legendary preparator. She actually just retired a few months ago, back in April, I think. Or maybe it was May. But yeah. So I wish her the very best. Wonder how much prep work is going to be done here without her work. She was incredibly fast.
Izzy says, Danny,
Yeah?
how long does it take to get the fossil out of the dirt?
Izzy, it depends. Like, how big is the fossil, and also, you know, it's funny, I just saw some of my colleagues walk into the back room there. I don't know if they saw me. But yeah, depending on the size of the fossil, it can take anywhere from, 2 seconds to 2 summers, or longer. It depends how big is the specimen, how delicate is it, and I don't know, how complicated is it to collect. Some dinosaur specimens, you just pick them up and you wrap them in aluminum foil and you're done. Some of them require a crew of 50 people and a helicopter to get out. Oh. This is really cool. Wow. You're looking at baby dinosaur bones right here. From Hypacrosaurus. This is a big duckbill dinosaur, but when they were babies, they were very small. And And these are probably from a nesting colony. A lot of these dinosaurs had nesting colonies, just like modern day birds. They were very, very social, and lived in groups like this. There's a tibia. This is like your shin bone of a juvenile, pretty small one. And there's an adult right there. Really big. Really big. These critters got pretty large. I've never seen this before. This is new here on display. Very cool.
Oh, they've got a little video right here. That's nifty. That's John Scanella.
That's pretty funny.
Did you?
Yeah. So I used to work with John. I spent a whole summer in the field with John in 2012, digging up a few specimens in the lower Hell Creek. He still dresses like he always did. He always wears all black in the field, which I thought, I don't know, I try and wear lighter colors just to keep cool. But I don't know, that's John's style. Yeah. Anyway.
Every summer, the Museum of the Rockies field crews come out to areas like this where we...
They're not out there right now. I saw other field trucks parked out there. They might be out there. I don't know what's holding them. But yeah. Oh, here we've got like a little mock-up of what a dig site might look like. Oh. Oh, a curator is somebody whose job it is... They're kind of like head of the museum, or head of like a specific department of the museum, maybe. If they're like curator of vertebrates, or curator of, birds or something. But they're kind of in charge of like some of the research funding and what goes on with collections and that kind of thing. It's kind of like a museum boss, I guess. But yeah. Got a Maiasaura bone bed right here. This is pretty neat. This is what you might see at like Egg Mountain, up near Shoto. And there's a few tools in there. I don't know. Yeah. Kind of cool they put that on display. Alright, we're going to continue on into the hallway of growth and behavior. Right here.
And that'll lead us into the Hall of Horns and Teeth,
where we have some of our favorite dinosaurs like Yoshi's Trike, Pax Rex, and all those ones. Before we do that, though, do I?
A very important, underappreciated section of the museum, where all the server farm.
Oh yeah.
It's dark in there. You might not be able to see that. It's all the servers.
They don't want us to see it, but I'm telling you, this is where some important stuff happens. Look at the.
I don't know what they run on this.
There's a speaker system up there.
This might just be the stuff for this room.
Yeah. Well, there it is. Behind the scenes.
Thank you, Ian.
Don't say we're not taking you behind the scenes, Chad. Okay. Is this server farm out of date with no feathers?
It certainly is, Missy Faye, yeah. Do we have any other questions before we continue on into here?
No.
Okay, cool. So this is the hallway of growth and behavior. So we're going to talk a lot about ontogeny and dinosaur reproduction, and see a lot of dinosaur eggs in here, including these. We were talking about like maximum size for dinosaur eggs. They're about this size. This is about as big as eggs can be. This is from a Lambeosaurine dinosaur. It's very difficult sometimes to determine which eggs come from which dinosaurs, unless you have embryos inside. These ones did not. But yeah, they're about the size of like a volleyball, maybe a football, a soccer ball. Yeah, this is about as big as dinosaur eggs can get. This is about as big as you can make eggs on land.
So big.
Yeah.
Huge.
Really cool.
Lambeosaurine.
So these are your big crested duckbill dinosaurs. Parasaurolophus, Corythosaurus, Hypacrosaurus, Lambeosaurus.
Big.
Yeah. Yeah. Got some unidentified theropod dinosaur eggs.
Wow, yeah, these are marvelous clutches of eggs.
Yeah, they look kind of like, they almost remind me of Troodon eggs.
Yeah.
Yeah.
It's a Unix system. Yeah, it actually probably is. Like, you joke, but it is. We were actually, okay, I have to tell you, Chad, we were talking about trying to go to the Museum of Computing.
The American Computer Museum.
Yes, what I said. And we would talk about streaming it. I don't know if you would find that interesting, but that's a potential activity.
Yeah. Give me a 3 in chat if you would like to see an iOS stream on her channel. From the...
It'd probably be on Paleontologizing's channel, but maybe we haven't quite figured that part out yet. I don't know.
Okay, okay. Give me a 3 in chat if you would like to see an iOS.
Tropical says yes. Okay, great.
Cool.
Awesome, yeah.
Well, if Tropical says yes, then
I'd
yeah.
love to see old computer stuff. I don't even know that much about it. It would just be really cool.
Yeah, that'd be really neat. We'll see if we can do that maybe tomorrow. Yeah. Maiasaura egg clutches right there. And here, yeah, some more Troodon eggs. Very cool. And yes, we still use the word Troodon here at Museum of the Rockies. We don't say Stenonychosaurus like the Canadians do. Yeah. Very cool. Bob Makela discovered and collected this. Bob Makela was Jack Horner's field partner for years and years. They were like a dynamic duo in the field until Bob passed away.
We didn't come here to fight with monsters. We came here to find fossils.
Oh, cool. So, let me show you Maiasaura eggs, and then some hatchlings, and then some adult material. Here's some eggs of Maiasaura. This is the dinosaur that made Jack Horner famous. The dinosaur that made this museum, basically. And at a place called... Well, okay, let me tell you a story real quick, chat. Back in the early 1980s, Jack Horner had just gotten back from Vietnam, and he was kind of doing a road trip across northern Montana, and he happened to stop in a little rock shop in a town called Bynum, Montana. And he's there just looking around, talking to the owners. They're asking him to identify different things, like different fossils. And right before he's about to leave, they said, "Hey, boy, we got one more thing that you should check out." And they go into the back room, and they emerge with a coffee can with all these little tiny bones in it. They're like, "What are these from?" And he takes one look at them, and he goes, "Holy cow, these are baby dinosaur bones. Nobody else has ever found anything like this before. This is the first of its kind." And he asked them to show him the original site at a place near Choteau, Montana. And sure enough, not only were there lots of baby dinosaur bones, but there were eggs and there were nests. It was a whole nesting colony of this duck-billed dinosaur. It was new to science. And in studying this, he was able to determine that as the young were there in the nests, they had a bunch of like vegetative material around them, which was kind of interesting. And they had eggshells there that were all crushed. So like the young had stayed in the nests and trampled the eggshell and crushed it. So they didn't just leave the nest immediately after hatching, they stayed there. And furthermore, here's a hatchling of this animal right here. Their limbs were not well developed enough that they could actually walk right after hatching. They had to stay there in the nest and be fed by their parents. So this is like smoking gun proof that dinosaurs cared for their young, which was incredible. This is another thing that helped change the way that everybody pictured dinosaurs. Like, they weren't like reptiles where they just kind of like, yeah, you know, their young just kind of run off and do their own thing. They don't abandon their young like a lot of reptiles did. They took care of their young, just like birds. So here's a cast of a hatchling Maiasaura right there. This is about as big as they'd be when they first hatched out.
Really, even at that age, it's so well articulated with all of its bone structure.
Yeah, yeah. But apparently the cartilage in their limbs was not well developed enough that they could actually walk. They could kind of like flop around in the nest, kind of like baby birds, like a baby robin or something like that.
Yeah. Like, they look like baby birds, to be honest.
Yeah. And here is a nestling Maiasaura. So they got pretty big. They stayed in the nest until they're like a meter long. There's a lovely Doug Henderson painting of Maiasaura, of a mother Maiasaura and her little nestlings. If any of you have any kids, you might want to check out a book called Maya, A Baby Dinosaur Grows Up. It was actually the first book that Jack Horner ever wrote.
A real mean kid.
It's like a story chronicling...
With 6-inch daggers for teeth, he was the terror of his
Baby
neighborhood.
Maiasaura. Anyway, he named this animal Maiasaura. The name means good mother lizard. Because, you know, this is like paleobiology. This is stuff we were able to determine about this animal's behavior from fossils, which is incredibly exciting. So ever since then, that's been like a big deal here at Museum of the Rockies, is paleobiology, determining, you know, how these animals actually lived and behaved and socialized. And, here's an adult Maiasaurus skull, by the way. So you get pretty big, like 20 feet long, like almost 7 meters. So yeah, Oh, and over here, I'll show you. These animals lived, we think, in massive herds. There's another lovely Doug Henderson painting. I think it might be from that book, Maya, A Baby Dinosaur Grows Up, by Jack Horner. So we found enormous bone beds of these animals. Up at Egg Mountain, it's been estimated that there might be like 10,000 Maiasaura, all in the same spot, that may have died like during a volcanic eruption or something. Just incredible.
Talking about the Maiasaur nest.
Yeah.
Did they figure out how the site came to be that way? Why so many died in a colony?
Oh yeah, probably was from a volcanic eruption, like just ash raining down from the sky. Yeah. And this would have been like near a shallow lake, so maybe like they all died there, and then the lake levels rose and then just buried everything, and yeah, bad for them, but very, very good for us as paleontologists. Yeah. And here we've got some lovely hadrosaur elements right here.
Javasaur says, didn't they find evidence that they reused the nests?
Yeah, this was like a nesting colony where they probably came back year after year. Yeah.
Really cool.
Yeah. It's really cool because I think that was Jack's first scientific paper that he ever published, and it was in either Nature or Science. It was in one of the big two, which is crazy. Yeah. Oh, here, this is just a really simple display, just showing you the hind feet of two different dinosaurs, an herbivore. This is a hadrosaur, Brachylophosaurus. Those big hoofs at the end. Those big pedal unguals, really robust. And then this is from a Daspletosaurus, an animal that shared the same environment. This is clearly a carnivore. Look at the sharp claws on those.
Javasaurus wonders, didn't they find evidence they reused the
Yes.
nests? Oh, you did not. Sorry. My bad.
No worries. All right. Oh, and I get asked this question a lot, so I'm really happy to share this display with you right now about dinosaur sounds. So yeah, we talked about the Lambeosaurine duck-billed dinosaurs. It's really cool hadrosaurs, big crests on their heads. And those crests not only were really good for display, but also they had air chambers in them. It seemed to be like, not for respiration necessarily, but for sound amplification.
No, I didn't know what these were, and I looked around and I was like, that looks kind of like a musical instrument.
Yeah?
Yeah.
Yeah, like a...
So, like, it's like something that would make sound like a resonating chamber or some kind.
What's that thing? Chat will know.
Okinawa or something like that?
What's the thing? iios from Zelda?
The ocarina.
Ocarina.
Yes. Happy to be of
There.
service.
So again...
Vuvuzela? Yeah.
Vuvuzela. I'm not a video game person, but I am a dinosaur person, and yeah.
Izzy says that the duck-billed dinosaur's feet remind her of camel's feet.
Yeah, that's really interesting, how the toes kind of splay to the sides like that. Izzy? Yeah. Pretty neat. Yeah. But yeah. So this is a juvenile Hypacrosaurus, and that is a CAT scan. Kind of like a computerized X-ray almost, of the air passageways, the red parts in its skull right there. Like I've talked about before, these guys, as they grow, that crest between the eyes gets taller and taller, and more exaggerated, and so it would have made a very different sound. So the adults and the juveniles would both sound very different from one another. There'd be a way for them to kind of keep in constant communication as they move around in a big herd. And chances are each of these dinosaurs would have like kind of a distinctive sound signature to them, so they could all identify each other by sound, probably. Kind of like with modern birds. Everybody's got, a slightly different song. Like, it's difficult for us to pick out, because we're not members of that species, but to them, I'm sure it's just like, when you hear the voice of somebody you're close to, and you instantly know that it's them. These dinosaurs are just like that. Yeah. Pretty cool to think about, having, like, rich social lives. Dinosaurs are such interesting animals. Partial skull of Avaceratops. This is a probably juvenile ceratopsian dinosaur. Pretty cool. Not a whole lot there.
Yeah, but even the fractional portion of it is pretty compelling.
You can still see kind of what's going on with it, right?
Yeah. Yeah, absolutely.
Got the eye socket right there, the orbit, the brow horn, So this is the front of the animal's face. This is the back. The frill would come off of there. This is the jugal. So this is kind of like the cheek spike coming off right there. It's broken, but it would be kind of pointy.
Kbot says, could dinosaurs have whistled like songbirds?
Maybe, yeah. It probably would have been a lower frequency if it's a bigger animal, but yeah. They had a lot of the same vocal apparatus, we think.
And then I know there was a recent discovery regarding hadrosaur forelimbs, but I was wondering, would the single hoof be a characteristic of all hadrosaurs, or just of the Edmontosaurus specimen was found on?
That's a great question. Yeah, I mean, we've known about hadrosaur forelimbs for a long time. There's those mummified specimens from AMNH. That seems to be something that's kind of like across the whole family. All of them would have had that kind of that mitten. Yeah, you could call it a hoof, I guess, if you want. Tomato, potato. But we know that Brachylophosaurus had that. We know that Edmontosaurus had that. It seems to be something that's kind of widespread across the whole group. Yeah. Good question. Yeah.
Are there any birds today that use hollow spaces to make different sounds?
There certainly are, yeah. I think cassowaries, the big casque on their head, is used for that. I think hornbills, their horned bill, it's also has some sort of a purpose for amplifying their sound. Yeah. But not in the same way that dinosaurs do. I mean, the dinosaurs is much more pronounced. This is super cool.
Yeah, it's wild.
Yeah, so this is the lower jaw of Edmontosaurus, big duck-billed dinosaur. And you're looking at the teeth right there. This is the lingual side, so the tongue would be right there. There's the jaw joint up there.
It's so interesting. You can even see the lines almost of the teeth go all the way down.
They do go all the way down to the base of there, yeah. So the teeth are just being pushed out all the time like a conveyor belt. Really slowly, but they'd probably go through a whole mouth of teeth multiple times a year.
Or something.
Yeah.
Almost like if you need to put wear on them or they would grow too large.
Well, I mean, they just fall out.
Oh, right.
They just get pushed out.
Right.
Yeah. And so right there, this is really, I love that they have this because I try and explain this all the time. And it's hard to find good diagrams online. But what you're looking at right there is if you were to take like a cross section of the jaw. So like you've got the upper jaw up there and the lower jaw right there. And that is how the teeth occlude.
Oh,
so they kind of like crunch or slide past each other as they chew. There's no other animal today that really has jaws that work like that, that chews in that way.
Yeah.
Really, really strange, but it seems to be a really efficient way of chewing. It's not just like us where the teeth just kind of mash together. Like they're kind of sliding past each other almost like a pair of scissors, like slicing and grinding at the same time. Really cool. That's probably one of the reasons why these dinosaurs were so massively successful in the late Cretaceous. They spread all over the world, and they seem to have tackled all different kinds of vegetation.
Tropical wonders of cows eat like that.
No, they don't. Cows are much more like us, where they do kind of like, they move their jaws from side to side a little bit, but it's still more like mashing than like scissoring, like cutting like that, like that with the two blades moving past each other. Yeah, I've got another sample platter of cool Judith River fossils. I've done a lot of work in the Judith River Formation. Yeah. So this is neat. This is this sort of context that's really important for understanding different environments.
Dark Raven says, my favorite audio interpretation of sounds is Saurian's Rex. Something like that with added non-spharynx/larynx closed mouth vocalizations.
Isn't that super cool? Yeah. Again, that game is awesome.
Imagine an 8 to 9 ton tyrannosaur making a cassowary or emu booming noise with their chest.
You could probably hear it from like 30 miles away.
Like thunder or something.
Yeah. Amazing. Yeah, very cool. And look, this is really neat too. Here's a tyrannosaur jaw right there. Probably Gorgosaurus or Albertosaurus. And you can see parts of it are like broken off. You can see those teeth emerging. So, do you see those eyes? Like the way the teeth are just starting to poke out there? So all the rest of the teeth would have fallen out after death.
Right.
But you still got those ones, those replacement teeth coming in, yeah.
On the diagonal says turtle beaks slice that way.
Yeah, they kind of do, don't they? That's a good point. Yeah, because there are a lot of herbivorous turtles, which is kind of cool. That's the way that they can actually like crop their food. And we've got some pachydomes right here. We saw some of these at at the Carter County Museum. This is the same cast of Stegosaurus that I have in my office, right there. And there's Pachycephalosaurid skull dome from up in Glacier County. You don't hear of too many dinosaurs from Glacier County, I guess. This is what the underside of the dome looks like. Pretty cool. Yeah, this is the biggest, most resilient part of that animal. Usually when we find a Pachycephalosaur, it seems like, 6 times out of 10 maybe, we just find the dome. That's it. It's a very resilient part of the animal. It's easily fossilized and it's easily identifiable. It's probably another big part of it. Now, this is super cool. This is Daspletosaurus horneri. They had to change the sign on this recently. It used to just say Daspletosaurus spa, like Daspletosaurus species.
And now it's a holotype.
This is, now a holotype of a new species of Daspletosaurus. Thomas Carr named this just a little while ago. It's probably got... Oh, it doesn't have the citation yet. But yeah, he did a really cool paper on anagenesis in tyrannosaurs. So we've got... This is a pretty old specimen, but then we've got geologically more recent ones of Daspletosaurus that look a little bit different. He is convinced and puts forward in the paper that this is an anagenetic series. That this is one species of Daspletosaurus evolving into another over time, which is really, really cool. That we can basically watch evolution take place in a dinosaur lineage.
Dark Raven says, the famous Carr non-lipped tyrannosaur find.
Yeah.
Fine.
Pretty cool, right? Yeah. When right after that paper came out, Thomas came out to visit us, and we had a Dead Lizard Society meeting where we went over his paper. It's funny, we'd never discussed a paper with its author before in a DLS meeting, so it was a little bit out of the ordinary, but it was cool. He did a whole presentation and everything, and it was neat.
Raven says, like the Triceratops horridus and Triceratops prorsus.
Exactly, yeah. Dinosaur anagenesis, this is like a new trend in dinosaur paleontology. This is an emerging field. We're finding more and more evidence for anagenesis, for lineage evolution from one species into another, rather than branching evolution. It turns out anagenesis might even be the dominant mode of evolution across Dinosauria. We're not really sure yet.
Gosh, this is a gorgeous...
Yeah, isn't that cool?
Fossil.
So those juvenile bones that we saw earlier of Hypacrosaurus and the juvenile skull over there with the resonating chamber, this is what an adult skull looks like. This is probably not fully adult yet. The crest probably gets even taller than that. But yeah, check that out. Really cool, right? Yeah. And my chat got disconnected.
How do you even learn how to say the dino science names? They are tongue twisters.
Lots of practice. I don't know. It's like learning a language. I've been at this since I was a little kid, so it comes totally naturally to me.
There is a scientific consistency to the pronunciations usually.
Yeah.
I think.
Yeah, this is true.
Yes.
Yeah. There's a lot of Latin and a lot of Greek. Here we have Ankylosaurus. Ankylosaurus horneri. This is the holotype specimen, so this is the original of this animal.
And it's not... So what differentiates this from a Triceratops?
A zillion things.
Yeah.
So Triceratops, everything looks different. Triceratops has 2 big brow horns.
Sure.
It's got a nasal horn right there. This animal just has these kind of nasal, it has a nasal boss, and bosses over its eyes. So it's just kind of like a rough patch. It probably would have been covered with keratin.
Interesting.
There is even a chance. I feel like I'd love to see more study on this kind of thing. This guy may have had horns on those spots too, but they may have just been keratin cored rather than having a bony core.
Dark Raven says Triceratops is a chasmosaurine.
Yes, and this is a centrosaurine. Yeah.
That's literally what they said. Yes.
So this is related to animals like Centrosaurus. Centrosaurines, traditionally, they're ones that have a large nasal horn and then 2 little brow horns, or maybe no brow horns at all. And Chasmosaurines have the 2 big brow horns and then a big squared-off frill. Centrosaurine frills tend to be rounder.
Did Triceratops demonstrate these, the holes in the frill?
Isn't that the question? Yes, we will talk about that in a little bit.
Very exciting. Getting ahead of myself.
Seriously, that's a huge topic. So Here, before we move on to the olive horns and teeth, let's take a look at some more of these displays. This is really neat. I'm excited to show you this. We have a Maiasaura growth series.
Oh, this is
So,
awesome.
isn't that neat?
Mm-hmm.
So dinosaur ontogeny is a huge deal at this museum. Ontogeny is the study of animals, like through their growth and their development, like within their individual lifespans. So like a frog going from an egg to a tadpole into an adult frog, those are changes in ontogeny. Dinosaurs also changed a lot through ontogeny. Maybe not as much as a frog, but still pretty dramatically. And here is just an example of the size difference between an embryonic Maiasaura, still there in the egg, up to an
Yeah, it
adult.
goes small
right
nestling,
there.
large nestling, juvenile, large juvenile, sub-adult,
Mm-hmm.
adult.
Yeah.
Wow.
Pretty impressive, right? So, and like I said before, we've talked about this a lot. A lot of mammals today, you know, they might, even the really big mammals, they grow a lot through their lifespan, but they don't grow this much. They don't grow this dramatically, you know?
Although it does, this graph does chart an emu's growth rate as being kind of similar
Yeah.
to a Maiasaurus.
Uh-huh.
Yeah.
Emu also hatched from eggs. So all dinosaurs, as far as we know, hatched from eggs. You've got big animals today like elephants. Elephants grow to be really big, but their babies are also very big too. They start off large. They don't have to go through this super dramatic, like growth series like this. They don't have to, you know, grow this much as they're out walking around doing their thing.
Aerospace has something to say about this.
Oh, yeah?
Do you think they would position themselves so that light would shine over the holes for display?
That's a great question, Mayor Space. I have no idea. I actually would love to talk to some ceratopsian researchers about that to try and figure out how much skin would be there over the fenestrae. Whether that would be like translucent or what. I don't know. Yeah. I know I've seen some reconstructions, usually really bad reconstructions. Like there's one in that Jurassic World movie where it's just like hollow. It's like you can see daylight through it. Which I don't think that was actually based on anything.
Probably, yeah.
Yeah.
I don't know.
But it seems to have had skin and probably keratin over it as well. Yeah.
Question for Danny. Is the term super adult a thing used by actual paleontologists?
I don't know if I've seen that in
Saurian.
Yeah. I don't know if I've seen that in the literature. It would be a useful term, so I could definitely see it getting picked up. And maybe there are some paleontologists who use it already. I don't know. I know I've never used it, and I don't think I've heard in my discussions with colleagues here from the museum or from other institutions. I don't think I've ever heard the term super adult, but I don't see why it wouldn't get used. Yeah.
Yeah, and cool, we've got some more dinosaurs at different growth stages here. There's a baby skull of Hypacrosaurus.
So there's the baby right there. Isn't that cute?
Yeah.
The big eyes on it.
Not neat, yeah.
Yeah. And then there's the adult right over there, just over iios' shoulder. So yeah, they change a lot through ontogeny. And here, let me make sure I didn't just disconnect the camera. No, we're good. This is going to be a constant theme in the next hall. Is when paleontologists, we would find, you know, immature specimens of dinosaurs, and they look very different from the mature ones, and we go, oh, looks different, must be a different species. No. A lot of the dinosaurs we used to think were distinct taxa, it's turning out, with more study, more specimens, more histological data, these are actually just the same animal at different growth stages, which is really cool.
Claire wonders if Achiliosaurus might be related to Pachyrhinosaurus.
It is, Claire. I think they might be sister taxa, actually. They might be each other's closest relatives. Pachyrhinosaurus and Ankylosaurus. Yeah. But it's, again, Pachyrhinosaurus. Got that nasal boss. Very good, Claire. Yeah.
Alicia says maybe they had skin with slits in the fenestrae so they could make whistling sounds when wind passes through.
There we go.
Wow.
Maybe they generated wind
whole
power.
Symphony.
I like that.
Now we will sing the song of our people.
Which is really cool. Just gives you a good sense for all the different animals in this environment. Paleoskinkus is a
I know, Paleoscincus, excuse me. That's an ankylosaur. Sorry. Hypacris.
Just a moment. Blue screen and then back.
Okay.
You're cutting in and out. Maybe we move from this spot.
5,000. Okay. All right. Is this any better? Yeah.
Repeating blue screens. I actually do see good feed right now.
Yeah.
Hold on a second.
Interesting.
Coming through.
That's what it always looks like at the bottom.
Great.
Yeah. Let's see. Coming back, okay.
Okay. Nope, actually you're no camera now.
What?
Now you're back. You went no camera for 1 second.
Okay. I'll try and just not move my hand on this at all. Okay.
Connection is stable.
Okay, cool.
I think I would worry most about the connection up here.
Okay.
Just keep an eye on it.
Yeah. I will. I'm just not gonna touch that at all.
Yeah.
Cool. All right. Before we venture into here, let. Take a look at.
That whole thing is a shell.
It's on there. How about now?
Now it's back.
Okay.
I think.
Let's just hold it like that. We've been dead before and survived, says Hannies.
Yeah, it's back now that we're standing still.
Okay.
Yeah. Thanks everybody for being so patient.
Yeah, I appreciate that. Here, let me.
A real dinosaur?
$20 seconds?
Well, I mean,
something like that. Okay. It's supposed to be 5.
Round trip time.
But yeah.
Numbers are,
yeah.
fungible. I don't know what fungible means. Can someone define fungible? To me, fungible is just a word that means Nothing. It means whatever you want
It means
to mean.
loosey-goosey, right?
Yeah.
Or something? Yeah.
I think we're count.
Okay.
5 okay, yeah.
Cool. All right. Well...
Tropic, okay. No one say the H word, which is heat. No one say that word.
No, it's not that. Yeah, here. Go over here, because there's no people here for a second. Remember at the Carter County Museum, I was showing you some Placentaceras ammonite fossils? Check this out. Look at that. So the colors that you see here are original. This is like the original mother of pearl of this big cephalopod animal. Look at how shiny and beautiful it is. Almost like abalone, but red. Very, very cool. So this is one of these ammonites, these big, like, coiled cephalopod animals.
Does that look really good on cam? People are freaking out about
It
it.
does look good on camera. I got it.
Yeah.
It's ammonite.
Yeah. Very cool. So these guys,
by the way, yeah.
these guys are one of the critters that actually go extinct at the end of the Mesozoic, at the end of the Cretaceous, along with the dinosaurs on land. So it seems like whatever happened, most likely a giant, devastating asteroid impact, also disrupted marine food webs enough that these guys perished.
Enormous ammonite. What the hell?
Isn't
Look
that
how
huge?
shiny it is.
I know, right?
And it's like a bright red.
That is the original,
iridescence.
like, mother of pearl from that animal.
It's enormous. Was this when the ocean had a different mixture of like?
No, would have been just like today.
So it could have grown this large. Could it grow? Ammonites grow this large today?
Ammonites are extinct now.
Right. Sorry.
Yeah, but
that's kind of a no duh. Sorry.
Yeah, no, it's okay. But like we've got nautilus today, which do not grow this large. They get at most maybe like that big. I'm like trying to do the outer curve with one hand. Yeah, and they're very, very beautiful too, but not. I think they would pale in comparison to the ammonites of the Mesozoic.
Little Bungorf says,
Yeah.
how did the color get preserved?
That's a great question, Little Bungor. I think it's a resilient enough material that, like, that could last literally millions of years. These animals, like, when they secrete the material for their shell, that stuff is really, really hard and really resilient. So, yeah. It doesn't always get preserved. Sometimes this stuff gets replaced by other minerals in the ground, but in this specimen, it was preserved. We got really lucky. It's beautiful. And this is not even complete. Like, this would be even larger.
This drawer contains
I don't know how many more coils
all
this would
of the
extend.
North American identified specimens.
We have ammonites from the Mesozoic that are like close to 10 feet across, like 3 meters from end to end. Just huge. Yeah, really cool creatures. And this is from Garfield County. It's where I've done a ton of field work, up in the Bear Paw Shale. So this is from just before, like, the Hell Creek Formation.
Kenny asks, is the color a pigment or an illusion, like blue butterfly wing color?
I think it's a pigment. Yeah. Because butterfly wings are like structural color. Yeah. This, I think, is the actual color. I think it is a pigment. Yeah. But I'm not sure. I forget what ammonite shells like this are made of. It might be aragonite, or it might be something else. But there's like an interesting composition to it.
Scooey.
Yeah.
We've been scooeying all weekend with K-pods. I've just been restraining myself for Danny's stream, but yeehaw!
All right, here. This is super cool. We have a mosasaur. So this is one of these giant marine lizards, also from the Bear Paw Shale. Actually, this is from Phillips County. Maybe it's not from the Bear Paw Shale. But anyway, these lived alongside the dinosaurs, but these lived in the oceans at the time. Imagine a Komodo dragon that's 40 feet long. Instead of arms and legs, it's got flippers. It's got a long, like, paddle on its tail. You just imagine a mosasaur. That's basically what this creature is. So look at those teeth. I mean, pretty cool, right? Giving you some sense of scale here. They get really enormous, up to about 40 feet long. That's, what, like 14 meters, something like that? 13 meters? And I don't know if you can see it, but it's got those pterygoid teeth, or palatine teeth, or whatever they're called, right there in the roof of the mouth.
Yeah, in the middle. What are
Yeah.
those for?
Probably just for subduing prey. Maybe it was like if it grabs a fish or something, it just gives it some extra purchase on it.
I don't know if those are kinetic. I don't know if they have any kinesis. I don't know if those can rake backwards like in a snake's mouth. Yeah, really cool.
Could they lose teeth like sharks?
Yeah, certainly. So just like lizards today, these are
correctly,
a mosasaur like this is related to varanid lizards.
What do
This
you
is a
think?
giant ocean-going lizard.
Do a research on that, Oliver.
Yeah, so just like modern lizards, they could lose their teeth and replace them. Again, that's the rule, not the exception. We, as mammals, who only have 2 sets of teeth during our lives, we are the weird exception there. Most animals can replace their teeth. And then we've got, speaking of replacing teeth, this one's got none.
Yeah.
All the teeth are pulled out, yeah. That's an elasmosaur skull. And see how you can maybe see a little bit how the tooth sockets kind of point forward. Their teeth would point forward too. They just have like this interweaving basket of really weird sharp teeth that all project forward. All right, and before we move on to the next haul, let me show you real quick a dromaeosaur, or a raptor dinosaur, as members of the public often call it. So this is a cast with some sculpted bits of Sauronitholestes. This is kind of like a North American velociraptor right here. Not particularly large, but it's got some beautiful, beautiful elements on it. You can tell the pieces that were real and the pieces that were sculpted. Like that femur right there. That's a cast of the real bone. But some other ones that are really smooth, like at the base of the tail there, those are sculpts. And do you see that little, like, very shallow U or V-shaped bone right there in its chest? Does anybody know what that is? You want to take a guess, Laurdee?
It's a wishbone. I'm going to go with wishbone.
It is a wishbone, yeah.
Sorry.
Yeah. No. Yeah.
Such a Hermione. I know.
Such a what?
Hermione from Harry Potter.
Oh, okay. Yeah. I mean, you see those ossified tendons on the tail, too? It would make it long and stiff like a broom.
Wow, yeah.
Yeah.
Yeah,
It's
so
very
it
stiff
wouldn't really
tails.
be, it would be stiff.
So, yeah, the base of the tail is flexible right there.
Uh-huh.
But you go further on.
The rest of it isn't.
Yeah, it's just broom handle stiff. Tail is held out behind it for balance. All right, now, what we've all been waiting for. The Hall of Horns and Teeth right here, including the only genuine mounted Tyrannosaurus skeleton in the state of Montana. This is Pex Rex right here. We saw a cast of Pex Rex at the Dinosaur Museum in Rapid City, and these are the actual bones right here. Pretty impressive, right? Yeah. So there's a few really, really interesting elements I'd like to point out. One of the cool things is the gastralia. It's got this kind of network, almost like a basket of belly ribs underneath. Like we were talking about before, parts that are dark brown are the actual fossil. And then the light brown parts, kind of tan parts, the parts that have been filled in. Yeah, so this has actual parts of the gastralia in there. It's really kind of rare to find a Tyrannosaurus skeleton with mounted gastralia. I do, yeah. There you go. Yeah. And right there's the furcula, which is the wishbone, like we were talking about. Right there in the middle of the chest. Pex Rex was the first Tyrannosaurus to be found with a furcula, with the wishbone, which is really cool. It was a big deal. There's a paper published on it in 2004, I think, saying like, wow, theropod dinosaurs had furculae. They had wishbones. It was Tyrannosaurus and Suchomimus, I think, in the same paper. Yeah, and if you look really closely at the hands, you can see there's like the remnant of digit 3 right there. Yeah. Just barely there, just a little splint.
So would it be under skin?
I don't think we really know. Yeah. I mean, here, the one on the right side, it looks like most of that is the actual fossil bone.
Look up to see more of the head.
Yeah. Okay. And there's the skull up there. Now, the skull is the only part of this animal where the brown is not real bone. The skull was too heavy to mount like that. So you'll see the skull, the real skull, back there, I think.
They look small, says Dr. They're the same size as your arms.
Oh, yeah.
And could lift 300 pounds each.
Yeah. It's still kind of a debate as to whether or not Tyrannosaurus arms were really useful for anything. I mean, an animal will use any part of its body, but like whether it was useful enough that it would be selected for, or whether it could atrophy without consequence.
there's a hypothesis, or like an idea, I don't know if it's a hypothesis. Actually, it's not testable, so it's not a hypothesis, I guess, by definition. But there's an idea that these guys, if they had not gone extinct, if that asteroid hadn't hit, if they'd been allowed to continue to evolve, that they would have just lost their forelimbs altogether. And I don't know, maybe like abelosaurs, they would have gone that route, where their forelimbs are just so useless that they'd be little nubbins, and then eventually they'd get close to disappearing. I don't know. But yeah. Let me show you Yoshi's trike.
Yeah.
Very excited about that. This is one of the first dinosaurs I ever dug up, and the first dinosaur that I've ever dug up that went on public display is right here. Yoshi's trike.
Check that out. Very cool. Longest brow horns on any Triceratops in the entire world, to my knowledge. Yeah. Very, very cool. What do you think, iios?
It's phenomenal, honestly.
I mean, it's
a bit piecemeal from this angle, at least.
well, yeah, and it's also not mounted correctly.
You don't think so? What's incorrect?
Everything.
The classic Danny, everything.
Yeah. It's really kind of embarrassing because it should be such a beautiful skeletal mount, but they really screwed the pooch on this one. Yeah. But you can still see me right now, right? Yeah. Anyway, yeah. This is a really, really unique, wonderful specimen. This is a Triceratops from the Middle Hell Creek, which is pretty rare. So stratigraphically, it's like, it's about 67 million years old. So like right from the middle of the Hell Creek, where not a lot of Triceratops specimens have been excavated or studied.
Yeah. Really cool. Enormous head on it. Just enormous brow horns.
The whole thing that you see right here is a cast. So none of the actual bones that you're seeing before you are the real fossil bones here on display. The real ones are downstairs in the collections. The reason why there's brown and white here is that the bones that are brown are the ones that we actually have the real fossils downstairs. All the white ones are sculpts. So those were just to kind of fill in the blanks so we could make a whole skeleton and put it up on display. But yeah, there's a lot of things wrong with how it's mounted. If you look at the
Dorsal vertebrae, do you see how there's like just these big marshmallows in between there? Like, yeah. All those vertebrae should be like almost contacting each other. The back should not be that arched. The forelimbs are all wrong. This animal should have like kind of a smallish body and just a big comical head on it. And of course the ribs are all...
Java says, is this the one that had the weird residue on the frill?
No, this is a different one, Java. That one's not on display. That was Mark's trike 2. That's down in collections. But yeah. This is an iconic Triceratops specimen. I just wish it were mounted correctly.
Funky says, so this is why Danny left. Okay, yeah.
Things like this, I guess. Yeah, I don't know. Yeah. But it was, I don't know. It's still a really special feeling to see a dinosaur that you dug up go on public display. I mean, that's incredible. It's a wonderful, wonderful feeling. Even if it is, even if it is all wrong. Yeah.
Was the little one unearthed next to the big one?
It was not. No, this is Juvie Trike 3.
So this was discovered either by Denver Fowler or by Warwick Fowler. I forget. But yeah, really, really important juvenile Triceratops
specimen. In fact, the one, the sub badge, I think it's the 3-month sub badge in chat, is based on this particular specimen. Really, really important one. It's got those cool backwards swept horns right there. It's got those nice pointy epis on the parietals and the squamosals. It's got that little button horn on it. Very cute. Very cute. Let's go like this to kind of give you a sense of scale. Yeah. Oh, it's kind of funny. When we were at Yellowstone yesterday, like seeing all of these animals walk around, we saw like some bison and stuff. And like you two were talking about how big the bison were.
Yeah.
That's funny. That would be like a smallish dinosaur. Like that would be like a young Triceratops size. Yeah, they. Wait, what?
Because you're salty about the dinosaur mouth.
I'm holding my tongue right now. Believe me.
It's the dinosaur.
Yeah, I don't know. Just like the hips are not articulated properly, and
They
like
seem a little.
limbs are all disarticulated, and the ribs. What's going on with the ribs?
They look.
This is the thing: is that when you're mounting a dinosaur skeleton and the whole thing is a cast or a sculpt, you can do whatever you want to it. You know. I understand when some like genuine dinosaur skeletons, when the actual bones are up there, might be a little bit wonky to mount them. But with this, you got free reign. So I don't know. It's still really cool. It's really cool to see a dinosaur that I dug up, on public display like this, and see it become so iconic. You can buy plastic models of this particular Triceratops specimen. There's a company called Eofauna that produces them. I have one. It's really cool. But they ought to remount this because it's.
Java says it looks more like a angry cat.
It does.
Than a
Yeah.
grazing giant.
Exactly. Back's all arched like it.
Why are his feet off the ground? Why wouldn't they be like?
I know, right?
Hey, you're asking me. Yeah. No, don't apologize. You're absolutely right. And also, they're just like flat like that. Like that's not how Triceratops hands work.
Okay. But let's talk a little bit about Triceratops ontogeny, actually, while we're on the subject of Triceratops. We'll go over there. Looks like there's no people there right now. Let's see.
Put the camera up, see where the light is.
Okay. So, as you see in chat with all the different Triceratops ontogomorphs, a lot of those are actually from here in Museum of the Rockies. And so check out this wall behind us. Look at this, iios and laurdee. Look at all these Triceratops specimens. This is a growth series of Triceratops, from like baby to adult. Really incredible. Before we see that, since there's some people here right now, let's look at these adult and subadult Triceratops. So not only does Triceratops change individually as they grow and mature, the species was also evolving, or the genus was evolving over Hell Creek times, in about the 2 million years represented in those rock layers. So I really wish they'd have a mature Triceratops horridus, but this is an example of Triceratops horridus right here.
RB42 says, so the horn thing is true.
Horn thing? I don't know what that means. Yeah. I think the 9-month sub badge is based on this specimen right here, MOR 1120. So, but yeah. Anyway, this is Triceratops horridus from towards the bottom of the formation, and then Triceratops prorsus up here. It's got shorter brow horns and a big, thick nasal horn. iios and laurdee, the Triceratops you took a picture with at the airport, that's this specimen right here. This is Mort, MOR 004. Yeah. Pretty cool, right? Yeah. So they've got a big fiberglass cast at Bozeman Airport.
Does 004 mean this is the fourth specimen in the whole collection?
So this actually predates the paleontology program here at MOR.
Wow.
This is a Triceratops that I don't know why they had. This used to be like a small town history museum, and then they hired Jack Horner, and he turned it into like a paleontology powerhouse. But yeah, this specimen was collected a long time ago. Affectionately known as Mort.
The curve of their horns, yes, the curve of their horns did change over the years.
Yeah. So here's another Triceratops prorsus specimen. This is one from the top of the Hell Creek Formation. So you can see it's got that long, pointy nasal horn, and kind of shorter, stockier, still pointy brow horns. So much different from Yoshi's trike, who's got those big, long, gracefully curved horns. Toward the top of the Hell Creek Formation, as these animals evolve, as the genus evolves, they all looked like this when they got a little bit more mature. This specimen right here is, I think this is called Joe's trike. Yeah, actually it is. Yeah, and there's the man himself right there, Joe Johnson. So you might recognize that name if you're like a Star Wars fan, or if you like superhero movies. Joe Johnston would come out and dig with us sometimes. He's a Hollywood director. He started off his career as a concept artist on the Star Wars series. So he designed like some things you might have heard of, like AT-AT walkers and Boba Fett and stuff like that.
Joe Who people say.
Joe Who? Yeah, I know, right?
Oh.
Joe Johnston.
I think they were serious though.
Oh, they were.
Yeah.
Oh, okay, yeah, yeah. Joe Johnston.
Yeah, but like for real.
There he is, right there. Yeah. There's the specimen in the ground. You can see the back of the frill right there. Yeah. So anyway, but yeah, Joe Johnston. He also directed October Sky and Jumanji and Captain America, Jurassic Park 3. That's how he actually became involved with stuff here at the museum. Is he directed Jurassic Park 3 and talked to Jack Horner. Jack Horner was the paleontological consultant on those movies. So, yeah, Joe's a really cool guy. He's come out and dug with us a number of times and like really down to earth. Joe's pretty awesome. So yeah, those of you who have been in this channel for a while will certainly recognize this little specimen right here. This is the UCMP baby trike. I have a 3D print of this at home in my office. But this is just meant to show you this beautiful growth series of Triceratops, to show you how they change, how the individuals change as they grow and develop. So they start off really small like this, just tiny little buttons for horns there. And then, like the edge of the frill just has these cool little crenulations. But then as they start to grow, those little crenulations kind of pinch off right there, and they become the episquamosals and epiparietals. Really, really pointy. The horns are starting to develop, kind of pointing straight up like that. And then as the animals get older, those epis start to flatten out a little bit. The horns start to show a backward curve like that. The nasal horn still isn't really fused on yet. It starts to do that the more that they grow. Horns are still pointing backwards. This is Juvitrike 3, I think. Like the one that we just saw back there. You see the epis are starting to fuse onto the edge of the frill. Horns are starting to straighten out a little bit here. Coming flatter in the back. Those spikes. Nasal horn is fused on. As...
Oh yeah, Concord mentions that the silhouettes are under the skulls too.
Yeah, yeah.
That's a very cool detail.
Isn't that neat?
Displays. Yeah.
Yeah. Yeah. So, pretty cool. And then, when they're more or less fully mature, they look like that. Basically, those epis that fringe the frill just fuse onto the back of the skull. Now, this is actually a little bit more complicated than this because we've got Triceratops. Not only do they change during their lifespans, but they're also evolving over time. And so we should really have like the regrowth series like this, showing the different, like at different times, Triceratops, they'll look a little bit different at each growth stage. Triceratops horridus, Triceratops intermedius, and Triceratops prorsus. These are like a mixture of all of those right here. So eventually, with enough specimens, maybe this museum would be able to have 3 different growth series for these 3 different species. Yeah.
Will you be okay if Laurdee and I take like 10?
Yeah, go for it. Yeah.
Maybe in a few minutes.
Let me make sure that I'll just have to periodically glance down and check, make sure my camera's still on.
Totally.
But yeah.
And if you also want to take a break, we can be tour guides, and Danny can go off and.
I'm okay.
Eat bonbons.
We're in the last like major room here.
Sweet. Okay.
So yeah,
we'll stick with it. Yeah.
Okay. Yeah.
Okay.
Yeah. Yeah. Here's Mort again. This is that same Triceratops from over there. This is a cast of Mort. So this is like adult, but it doesn't seem to be a super adult like someone mentioned earlier. This is still controversial in the world of dinosaur paleontology. I've been convinced that this hypothesis is the real deal, but not everybody is yet. There's this other one over here. It's been known as Torosaurus in the past. So,
enormous.
Yeah, so it's big, and that's the thing is, you never find a small Torosaurus in the Hell Creek. You never find a juvenile Torosaurus in the Hell Creek. So the question became, A, how is this different from Triceratops, other than the big holes in the frill? And where are all the juveniles? We found juveniles of just about every other dinosaur in the Hell Creek Formation. Where are the juvenile Torosaurus?
It's interesting they use Mort again for this one.
Yeah.
Like a cast of MR.
Yeah. It's one of the best preserved Triceratops prorsus we have. It's all in one piece. It's very solid.
Yeah.
Yeah. And so anyway, with Torosaurus, the question is like, well, where are all the juveniles? Where are the baby Torosaurus?
Show me the babies.
And so, at Museum of the Rockies, we've become convinced that there are no juveniles. Torosaurus is just a fully mature Triceratops. That's the idea. And, I mean, there are more specimens of Triceratops here at this museum than any other museum in the world. And there's some stuff I can't talk about yet, but I don't know. Once some publications finally go through, I think everybody's going to be convinced that Torosaurus is indeed Triceratops. It's just a matter of time. There's some interesting stuff going on in terms of heterochrony, where we don't find Torosaurus at the top of the Hell Creek Formation. We only find it at the bottom. So Triceratops might be undergoing pedomorphosis. But yeah, anyway, there are people who are sitting on some specimens who, once those are published on, it's a done deal. But I don't know. Time will tell, you know? But really, the only major difference between Torosaurus and Triceratops is those fenestrae. And it turns out some Triceratops have that too. Nobody's calling them Torosaurus. So, I don't know. It's very arbitrary, the difference between the two. So yeah, here, let me scoot over here. Excuse me, Laurdee.
Why do you think the horns alternate from hooking backwards and forwards?
That's a great question. Well, it's something that happens with, like, through maturity. So for whatever reason, it was really important for these dinosaurs to be able to tell who is young and who is old. This might be something to do with social structure or something like that. Hang on. I've got some colleagues over there right now, and they're taking a photo. I don't want to interrupt them. But yeah.
Yeah, I think there's a lot of mystery around why the frills are like that. People have some questions. Well.
Oh, you mean people are asking questions?
Sure.
Yeah.
There are no juveniles because Torosaurus just spontaneously generate as fully formed adults. You know,
exactly.
We lost the secrets, Mayor. We need to refine the secrets of spontaneous.
Being right quiet right now. I've got so some of my colleagues are right there taking a picture, and I don't know if they're going to want to say hi or not. I'm not going to press them, but yeah.
You're welcome to if you want to hand off the pack to me for a second.
Yeah? Would that be cool?
Yeah, absolutely. Yeah.
Okay. Hang on, I'm going to transfer this over real quick. Hopefully we don't lose the camera connection. Here, guys. Hold that.
Yeah. Does it go under? Hi, everybody.
Yeah, it should go under there.
Great.
There you go. All right. Thanks.
Great. Hello. We're going to look at some more dinosaurs. While your star, Danny Anduza, does a little lad handing.
This is so cool. I've never seen dinosaur fossils like this. Maybe when I was a little kid, I've been to a museum, but never like this before. And seeing the different Triceratops changing throughout their lifetime is so interesting.
Mm-hmm. Yeah. So these are the really big ones. The next shield brow bone of Triceratops horridus. The lower shield is the original fossil facing forward, and the shield above is a cast showing the rear side. Oh, very cool. Okay. So you can see both sides of it. Note the pattern of blood vessel grooves in the front and rear of the shield. Yeah. I can take my phone if you want to go back to me. No, it's completely fine. Yeah. This is good. We're letting Danny get a chance to do some saying hi. Yeah. Very casually, exactly. Drobosaurus, exactly. What age range did the Triceratops have over the whole display just seen as an example? This is a good question. You know, I don't know that they give specific years. You know, I think they characterize them as like, well, this is the biggest one we found, so this is the most adult, maybe? It's a very good question, though. Sorry, I'm not as good at this as Danny is. I unfortunately am not quite as experienced. And I think I'll have to prepare you all if we do go to the American Museum of Computing or whatever. Tomorrow, I will also not be as skilled as Danny at doing tour guiding. You thought there were multiple back and forths. Were the horns hooked forward or back for the really young ones? The young ones have them forward, I think, Moosey Fate. Wait. No, I'm sorry. The young ones have them back, Moosey Fate. And then the older ones seem to have them forward. And we can kind of look, see. Sorry. Oh, thank you, Izzy. Well, I got them all done. I'm happy to talk about my tattoos. Yeah, so forward horns, then you see the younger ones have them more upwards. Yeah. I got all of my tattoos done with one artist. They're all themed from a tarot cards, a specific deck, really. And it took me about 1.5 years with one artist in particular. And there's some information on my channel if you really want to know more. But it was a lot of fun to get them all done. Throw in some chemistry and bam! Dinosaurs and computers? I know, we'll go see them. I'm actually genuinely really psyched to see the computers. Yeah.
Museum tour tomorrow, probably like noon Mountain Time, like it was today.
Yeah, like it was today, around noon Mountain Time. I'm really glad Danny's
going to
make a
Discord post about an hour beforehand.
Yeah, we'll send out some more information, but about the same time. Vintage computers, yeah, just really cool stuff.
What have we enjoyed about the museum so far?
Frankly, just being able to hang out with Danny here. Why don't we walk? I'm going to walk a little bit. Frankly, just being able to hang out with Danny and hear his perspectives, on so much of the stuff here.
It's been such a treat, honestly, getting to talk to Danny about these things because we don't have to read the plaques. He just tells me.
Yeah. This is a Triceratops pelvis bitten by a T-Rex. Wow. Studies determined that the T-Rex had bitten the bone with a bite force of 2,900 pounds, a force proportionally similar to the bite of a hyena. Wow. So where are these bite marks? I guess... Oh, with the red markers. Yeah, you can see. Sorry if I'm carrying around. He's like a kid in a candy shop, exactly, Glenn. Exactly. You're gonna be on a hot date tomorrow. Nice, Ayakane, nice. Well, priorities, Ayakane. You're busy then? I'm sorry, K-Pops. UTC? That's a good question, Darkness. You would have to do a conversion between noon Mountain Time. I'm not off the top of my head sure what my offset is. Is Dottie here? Hey, Dottie Matrix, welcome. Yeah, thank you for the lovely question. Yeah, being able to, it's one thing to look at the exhibits and to read the plaques and stuff, but then Danny has the skill of articulating, the history and the social context and the scientific context. And particularly, he has this eye on the historiography. That we kind of need a different word for the historiography is like the history of history, which is basically what it is here. But it's like the history of the science, and I find that really cool. I'm gonna keep walking just a little bit so we can see some more stuff. Danny will catch up with us real soon, I'm sure. That infectious enthusiasm, yes, agreed. Transistors the size of light bulbs, yeah, we're gonna see them.
It's gonna be really, really cool.
Yeah. They did dig in deep, Java. Must have been hard on their teeth to dig into that bone, honestly. Your ex, yikes, Ayakane. The lesson is don't get bit by a Tyrannosaurus. Yeah, don't get bit. I think Mayor of Space, it's rare that I would recommend being bitten under normal, operating procedure. Izzy, they may be getting louder. I'm talking quieter. Sorry, Izzy. I'm trying to be inconspicuous, and I'm probably being quiet.
You look like a Pokemon trainer.
I look like a Pokemon trainer? Nice.
Nice.
Gotta catch them all, Kate. Gotta catch them all. So this is a gorgeous... It almost looks like a duck-billed... Yeah, it almost certainly is. It's an Edmontosaurus. Yeah, beautiful nasal cavity. You can see the teeth.
I'm interested in your island. It's got nothing to do with oil. I'm a paleontologist.
You're not even a good liar.
Exactly, but it's just a gorgeous specimen. It's so impressive to see the collection here. You know, I've heard Danny talk about it a lot, but it's an entirely different thing to be here in person. Sorry, Izzy. I'll try to speak up a little more. A bite is okay if you seek to become a vampire or a werewolf. Yeah, I guess then that's like part of the operating procedure. Don't be nervous. Thanks, Izzy. Thanks. Danny can read the plaque that describes the plaque. He just has that skill. That pelvis has T-Rex teeth stuck in there and overgrown, meaning the animal survived the attack. Yikes. Oh, amazing! Lenina, I'm so happy that you had a good experience, and it makes it easier. It takes the edge off. It's already a painful experience to get a tattoo. Here, I'm gonna walk. We're gonna walk. It's already a painful experience.
It's a good thing I kept that other HDMI cable here in the bag.
You know, the notion that swapping HDMI cables would fix something like this is makes me question my sanity. Let me put it that way.
Now you know my relationship with technology. Now you understand us. For every single issue that I've resolved with this thing over the course of this road trip has been something like that. Yeah. Something that just doesn't make any sense. None of this makes any sense. It is insanity producing.
Good job. Really good job.
Thanks. But we got it.
Good
for
job,
everybody
Danny.
for everybody who stuck around during all of that darkness there, congratulations. You have received a Paleontologizing Medal of Patience. So thank you for that. But yeah.
Yeah, Danny's a wizard.
Anyway.
He and Tech just don't get along.
I don't know. But let's check out some dinosaurs over here real quick. Good. I only actually got to talk to Scott really quick. Everybody else just kind of ran off. Maybe they were busy. He was mostly like, it was really cool to catch up with him for a little bit. And he was just explaining all the travails that they've had with COVID. I think he was kind of apologetic about MOR not having done a lot of field work in the past couple of years. Montana State's policies regarding COVID have been really kind of draconian to the point where, like, they couldn't even take on any volunteers or students or anything to do field work with. So yeah, they basically haven't done much at all in the past couple of years. But they're looking to do some soon, hopefully, and I hope they do. But they've got big plans for, like, revamping parts of the museum, which is pretty exciting. All right, let's get back to the tour real quick. Here we've got some ornithomimosaur material. These are the ostrich dinosaurs. Really well known. And here, we'll see this when we go outside, too. Well, you've got the metatarsals right there on this animal. Look at how that middle one is all pinched out right there. This is the arctometatarsaline condition on the hind limb. Like, basically, these bones just kind of, like, squish together like that to form this solid, shock-absorbing mass. Really neat. There's an ilium right there, in the upper hip bones. And there's a reconstructed replica of Ornithomimus skull. It's about life-size. This model is way out of date. This animal should have feathers all over its body. It should look even more like an ostrich. But it's kind of cool that they've got something that people can look at in 3D to give them the basic body shape of this animal. Does anybody know what this is? Yeah. Let's see. How many people do we have watching right now, by the way, too, I wonder? Even after all of that dark... Wow, everybody. I am flattered. Yeah, that's awesome. Thank you, everybody who stayed. We've got an ankylosaur tail club right here. You can tell this is like a plastic, hollow cast of the real thing. There's probably replicas of this in all different museums around the country. But yeah, that is actual size for one of the tail clubs of this animal. Just a solid, massive bone with this stiff kind of handle of a tail right there. You can see the vertebrae right there. There would have been ossified tendons would also help hold this in place. Really kind of more of like a sledgehammer than a club, if we're being literal about all this. Yeah. Here's a nifty little model of an ankylosaur. This is a little bit out of date for Ankylosaurus. We now know it had kind of more rounded osteoderms around its body, rather than these pointy ones around the edges, but really cool nonetheless. And here we've got some ankylosaur armor bits.
Darkness wonders if bone combination is common or convergent evolution. because T-Rex has the same solution as well?
Oh, for the arctometatarsalient condition? That's an excellent question. This is actually because those animals are related. Ornithomimosaurs and tyrannosaurs are pretty close on the theropod family tree. So that's something that both T-Rex and Ornithomimus inherited from their common ancestor. Great question, yeah. Here we've got some ankylosaur scutes over here, what we call osteoderms. These are the armor plates. All these cool little pits on them.
Java wonders if the rigid tail or the club evolved first.
That's a great question. I think the club probably... Well, they evolved in tandem, but I think early ankylosaurs, they start to develop like a rudimentary club before the tail gets stiff. This is like the final endpoint. You know, like this is as developed as they get, only because these animals go extinct at the end of the Cretaceous, 66 million years ago. If they'd been allowed to continue to evolve, who knows what kind of shapes and sizes they would have reached. Speaking of ankylosaurs, I remembered I was going to show you this. Take a look at this, everybody. This is a skull cast of Ankylosaurus right here. This is much bigger than my Euplacephalus skull that I have in my office, because this is a bigger animal. Ankylosaurus, I think, is the largest of the ankylosaurs, but it's just a solid box of fused bone. I mean, check that out.
Paramedics wonders how many dino species have tail clubs like that.
There's a few. The ankylosaurian ankylosaurs tend to have that. There's got to be at least a dozen of them. Probably double that, actually. And there's even some sauropods that develop tail clubs, like Shunosaurus. It's different, like they're not related. That's convergent evolution, I guess, like two unrelated animals kind of evolving the same solution to a problem. In this case, problem predation, and they evolved a tail club to defend themselves, we think. Check this out. Just a solid box of fused bone right here. And there's laurdee and iios to give you some sense of scale. Pretty cool, right? I wish this had the eyelids in it, because these guys, believe it or not, had solid bone eyelids. And I always ask myself, like, what kind of a lifestyle are you leading where you need solid bone eyelids? Like, what are you doing in your daily routine where that's something that you would evolve? Solid bone armored eyelids. These probably would have been pretty slow-moving dinosaurs. Big hindgut fermenters. Maybe that armor was necessary for them to be able to deal with predation pressures. That's armor and a tail club. Maybe these guys were just particularly delicious or something too. I don't know. But for whatever reason, they evolved really crazy levels of armor. And even like offensive/defensive weapons like that tail club. I mean, yeah, I don't know.
Literally hardcore? Yeah, pretty much.
Yeah. Really neat. I forget how big these guys' skulls are. This is so much bigger than the one that I have in my office.
Yeah, yours is like half size or something.
Yeah. That's Euplacephalus. This is Ankylosaurus. I think the original is in the American Museum of Natural History. But this is from right here in Montana. Yeah.
Ankylosaur armor does seem overachieving considering they're known predators. It makes one wonder if we haven't found something. There's a bit of predator behavior we haven't guessed at yet.
Well, I mean, no, they had crazy predators, like Tyrannosaurus behind me. I don't know, yeah. Let's take a look at Thescelosaurus real quick. This is a really cool specimen. So this right here is a cast of the original. The original looks just like this, but it's downstairs in collections. And, the original is extraordinarily heavy. I don't know how many thousands of pounds it weighs, but they were kind of worried that if they brought the original up here and put it on display, that it would just crash through the floor. It is that heavy. So this is I would say a small beaky plant-eating dinosaur, but like everything in the Hell Creek Formation, they get really big. Right toward the end of the age of dinosaurs, about 66 million years ago, you have the largest representatives of all these different dinosaur families, from Tyrannosaurs to Hadrosaurs to Ceratopsians to Ankylosaurs, and these guys. Thescelosaurus is really big compared to its relatives. This is from Makoshika State Park, and as this specimen was incredibly heavy, they actually had to call in military air support to help get it out. That is a Black Hawk helicopter from the Montana National Guard. Or sorry, the Army National Guard. Pretty neat. And this is in an extraordinarily hard sandstone. The original, like, you'll see how there's all these, like, kind of, there's like striations running through the matrix right there, running through the rock. Those are air scribe marks. There were like 3 different people that this specimen gave carpal tunnel to, apparently.
Really?
Just nuts. Because, yeah, you sit there with these little pneumatic drills, these air scribes, and you just be, like, trying to winnow away this extremely hard, iron-rich sandstone. We call this ironstone in the field sometimes. The bone itself is much, much, much softer. So I've heard it described as, like, trying to chisel a marshmallow out of a concrete block.
Wow.
Yeah.
For real?
So not only is it really labor-intensive and time-consuming, but kind of nerve-wracking, too. So yeah, there's some very interesting stuff going on with that radius right there. What are those little prongs on the radius?
Yeah.
I don't know. But I'm guessing it's going to be pretty interesting once we figure it out. Yeah. Anyway, let's check out some pachycephalosaurs over here.
Yeah.
Oh, do we have some questions in the meantime?
Somebody was excited to see Sue. I was wondering if Sue was on display.
Oh no,
here.
Sue is not on display here.
Oh,
Sue is
okay.
in Chicago.
Gotcha.
But we have, I would argue, a better Tyrannosaurus here. But I'm not going to get into that.
Mr. Dean was hypothesizing that maybe the ankylosaurs had they would get into brambles or something, a lifestyle that made them vulnerable.
Maybe, yeah. I've heard it also suggested, kind of in jest, that they would just go and tackle ant mounds of biting ants.
Yeah.
And they just snuffle around and eat all the ants, and then close their eyes when the ants try and bite their eyes. But I don't know. It was a funny little idea. But here we talked about this at the Carter County Museum, but here we've got casts of all 3 of these. So these used to be considered 3 different dinosaurs. Dracorex, Stygimoloch, and Pachycephalosaurus. And nowadays we recognize these as being 3 different ontogomorphs of the same animal. From young to medium to fully mature. And yeah.
Mr. Dean says, so is it officially accepted that all 3 are the same species?
That's the thing. In the sciences, there's not I don't know. This isn't like astronomy where we hold a meeting and take a vote on whether or not Pluto is a planet or whatever. There's no planetary society type equivalent for paleontology. So here it's just do other paleontologists, accept that, and do they put it in their papers or do they not? And in this case, almost everybody agrees that these 3 are the same animal. Yeah, there's a broad consensus about that nowadays. There's a few other dinosaurs in this room where there's not that strong a consensus, but we'll talk about that. Yeah. But yeah, it's pretty dramatic that not even a huge change in size, from Dracorex to Stygimoloch to Pachycephalosaurus. But yeah. Do you know where that name Dracorex? You know what its species name is?
No.
It was named Dracorex hogwartsia.
Really?
Because I think the Children's Museum of Indianapolis held a naming contest.
Very nice, yeah.
But its name means Dragon King of Hogwarts.
It has a certain dragony kind of look to it. You can't deny it.
Yeah, J.K. Rowling actually commented on that after it was published. She said oh, it does resemble a, and she named some Harry Potter dragon that wasn't from the
Bugdorf says the second one is an Argonian skull.
I don't know what that is.
I'm not sure what that is either, yeah. And then Maximus Midnight says ontogeomorph.
Yeah, ontogomorph, yeah. Yeah. So, pretty neat. Yeah, we looked at the same cast of this Pachycephalosaurus skull. They had the cast of the same specimen at the Carter County Museum, because that's where this is from, Carter County, out in southeast Montana. You can see the original at the Museum in New York nowadays, I think. But yeah.
Is it possible that the dome may have fell off during its lifetime?
No, the dome is part of its skull. That's the really interesting thing. It's not like deer antlers or anything like that. It's its brain is in, it's not inside the dome. Its brain is in behind its eye. But, yeah. Anyway, should we go see some Edmontosaurus next?
We're going to take our 5 to 10 and then we'll be back.
All right, sounds good. Yeah. All right, let's go check out. Oops, we're on battery power now for some reason. That's odd. Actually, you know what? We've got some people over by Edmontosaurus. Let's check out T-Rex real quick. Well, you know what? No. Sorry, I'm being indecisive. We'll check out Edmontosaurus first. So, the biggest animal in the Hell Creek, the biggest dinosaur, is not Tyrannosaurus, as a lot of people think. It's actually this critter right here. Edmontosaurus actually gets marginally bigger than Tyrannosaurus. It's a big duck-billed dinosaur. This is a specimen called X-Rex, because when it was discovered, I think there were some volunteers from Portugal. Became known as the Portu Girls. And they discovered this. And Jack Horner took a look at it, and it was really, really big. There was only like a few pieces exposed, and it was so large that he said, oh yeah, it's got to be a Rex. It's a Tyrannosaurus. So they nicknamed it X-Rex. That's the specimen name, not the name of the genus or species or anything. Yeah, this is just the tail that you're looking at right here. That's like a solid like 25 feet long. Just tail. These animals are up to like 50 feet long. They get larger than Tyrannosaurus. One of the really cool things about this specimen is, look at those red arrows pointing down. You've got skin impressions right here. There's the most beautiful one right there. Nice pebbly skin texture. Shows you what the skin of this animal would have looked like. It's just beautiful. Really, really impressive specimen. Actually gives you a sense for what this animal would have looked like in life. And so, like with Pachycephalosaurus or Triceratops torosaurus, Edmontosaurus has also seen some kind of consolidation over the years, like these other Hell Creek dinosaurs. So it used to be that we had Edmontosaurus. Well, I guess 3. Edmontosaurus, Anatosaurus, and the Anatotitan. We saw that Anatotitan skeleton at the Carter County Museum. Yeah. Mr. Teen says so probably would not see a Rex going after one of those Edmontosaur bulls, or matriarchs, as the case may be. Maybe, Mr. Teen, but actually, maybe you would. This is not a full-grown one right here, but this is pretty cool. We've got an Edmontosaurus skull. It's a big one. It's not like full grown. Look at that little red dot right there. Look at where my shadow's pointing. That is a Tyrannosaurus tooth, actually embedded in the nasal bones, in the nose of this Edmontosaurus. Extraordinary, right? And I'm not absolutely positive, but I bet you there is some evidence of healing around it. Like this happened while the animal was alive. It somehow it survived an attack, or at least a bite, from this Tyrannosaur. And ended up with a very interesting looking souvenir right there. Check that out. Super cool. Yeah. So I don't know, maybe that wasn't from hunting. Maybe an Edmontosaur wandered too close to a Tyrannosaur nest. Got a bite from mom or something. Who knows? It's not like we can really test that. But yeah. Pretty cool. As I was saying though, ontogeny is really important when we're talking about Hell Creek dinosaurs. And there used to be 3 different hadrosaurs that people would talk about from the Hell Creek. Edmontosaurus, Anatosaurus, and Anatotitan. It turns out there's probably just one in reality. The really big one, Anatotitan, its name means giant duck. It's probably just a fully mature Edmontosaurus. And that is the hypothesis that's put forward here at Museum of the Rockies. I personally buy that. I think that should be our null hypothesis, is that these are probably the same animal, unless they can be demonstrated otherwise. Knowing how much these animals change through ontogeny. But yeah, anyway, look at how big this is. Really, really enormous. This would be like,
This would be maybe like a, I don't know, 16-meter long animal. Just enormous. Truly, truly large. Like the size of like a city bus. Like 50 feet long. And look at that bill at the front. And all those beautiful teeth in there. You can see the dental battery. There are multiple teeth, multiple rows that would be in contact. Like multiple teeth form the grinding surface. Like multiple rows of teeth. I'm not explaining this well. Apologies. But yeah. Really, really cool. There's the orbit, the eye socket right there. And there is the nares. The nostril. Look at that beautiful bill right there. Yeah. Paleodentistry. I know, right, Trek nerd? Very cool. This bill would have been covered with part of it flesh and part of it keratin on the front. So, really very distinct from a duck's bill, I suppose. It would have been much more, probably less sensitive and far more robust than an actual duck's bill. But they still take the name duck-billed dinosaur. A lot of paleontologists don't use that phrase. I think it's useful. I think it's useful for communicating to people who might not be super familiar with these animals, you know, what we're talking about. Hadrosaurs, duck-billed dinosaurs. People know what you're talking about then. And then if you want to, you could talk about how they don't really have duck bills. But yeah, I don't know. Musafate says, what was their bill for? Like plant grabbing leaves? Yeah, basically like a big cropping mechanism. Almost like the beak on a big tortoise or something like that. Yeah, for just grabbing big masses of vegetation and helping to like crop it so that it could be pulled into the back of the mouth and then chewed. These are some of the few dinosaurs that would actually chew their food. That's why they've got all those hundreds of teeth, hadrosaurs. Yeah. Anyway, let's take a look at Pex Rex a little bit from this side too, before we look at the growth series for Tyrannosaurus. Check that out. Again, the dark parts on here are the actual fossil bone, except for the skull. The skull is all sculpt and cast. The original skull is over there. I'll show you. It's too heavy to mount up there. Yeah, and look at that. Look at the metal armature. Just like, this is really the most time-consuming and labor-intensive and expensive part of mounting a genuine dinosaur skeleton, is coming up with this metal armature to support all of the bones. And still have them be removable for study, if need be. But have them be safe and secure and out of reach of visitors who might want to reach out and touch them. Yeah, very cool. That basket of gastralia, the belly ribs down there, kind of form silhouettes. So they go, this is, you know, the belly would extend from there all the way down to the pubic bones, and the gastralia would help support that part. Guts over here are supported by the big pubic boot on the pelvis. But over here, that basket of belly ribs just keep everything in place. And yeah. Let's see. Nanzen, I'm so glad you're liking this. I'm enjoying this too. Apologies for the technical difficulties, but I'm glad we got them resolved. It's great to be here with you. Yeah. Oh, this is super cool. I'm really excited to show you this. Right here. I know I've talked about this specimen on the channel before. Now I get to show you in person, which is super neat. This is the ventral side of a Triceratops pelvis. It's a sacrum right here. See, this is big ilium, one of the pelvic bones. Here are the sacral vertebrae. So you're looking at, I guess if you're looking at it like this, you are like upside down looking up at the underside of a Triceratops, at its hips. So, yeah. This is not really... I mention that because Triceratops is a great big animal and it's got a lot of flesh under this part. So like to be able to get to this part, it has to be like completely disassembled basically.
But get to this part, somebody did. You see these? Look at my shadow right here. These red arrows right there, they're pointing to these gouge marks and scrapes and punctures. Those match up with Tyrannosaurus teeth. Some of these, like the big one right here, if you actually take like some Play-Doh or something and you stick it into it and you pull it out, I've seen Greg Erickson do this. It comes out in a T-Rex tooth shape. So that's what was making these scrape marks and gouges and everything on the ventral side of a Triceratops pelvis. It's just crazy. So the Triceratops had to be on its back when like everything disassembled for the Tyrannosaur to be able to get to this point. So it just gives you some sense for like what amazing carcass processing machines these animals were. Just incredible. Incredible. We don't have anything like that around today. Nothing on this scale. I mean, look at that. Here, I'm showing you the teeth in front of X-Rex's jaws right here. So tyrannosaurs exhibit a certain degree of heterodonty. Not all of their teeth are identical to each other. Teeth from different parts of the skull and jaw are going to be shaped a little bit differently, and they're going to be sized differently too. So right here, we've got some small teeth in the front, along the premaxilla, and at the front of the maxilla right there. These are like kind of little nipping teeth right at the front. And again, there have been some studies of tyrannosaur bite marks, not just like on the Triceratops sacrum, but on like Triceratops skulls and other elements. And they show that those little nipping teeth in the front were used for like scraping little bits of flesh away from things like the occipital condyle on a Triceratops, the big like ball and socket joint on the back of the head, which I'll show you in a minute. It's right over there. Yeah, and then the big teeth along the sides of the maxillae, and
this drawer
the main
contains
part of the dentary.
Almost all
those are like
of the
big,
North
thick
American
teeth.
identified specimens of
Probably used
Troodon.
for, puncturing, tearing, crushing, especially crushing. Tyrannosaur teeth are really, really, really big in cross section, and yeah, just cool. And it's really interesting in that, as we'll see over there in just a minute, Tyrannosaurs change tremendously through their ontogeny. I mean, they start off as pretty svelte, lightly built, kind of lithe, really fast-running carnivores. And later, as they get mature, as they get older, they really bulk up. They just become these huge, hulking, like carcass processing machines, like the one you see behind me. So these dinosaurs are occupying several different niches throughout their lifespan. And there's a paper that just came out about this a couple of months ago, about how like medium-sized theropod dinosaurs are really rare in certain formations. Like medium-sized ones that are medium-sized at full growth, like when full grown. And it's probably because of the advent of tyrannosaurs in some cases. It's like, and these guys, the juveniles are taking up those medium-sized carnivore niches. They're doing that job, and so they're just out-competing whatever other creatures try to evolve to fill that. In fact, we've got some more people coming in. Let me show you the Tyrannosaurus ontogeny display right now. And Peculiar Princess, it is a little bit weird live streaming in front of the public like this, but I'm trying to be as unobtrusive as possible. Yeah. So, here's the placard right here. And then here are the specimens. This baby Tyrannosaurus right here, MOR 6025, I think? Yeah, 6625, sorry. I should know this, I helped dig it up. This is Chomperex. This is a 3D print produced by Larry Whitmer's lab at Ohio University. In 2013 or 2014, I helped dig up this critter in Garfield County in eastern Montana. The world's youngest and smallest T-Rex. It's kind of a funny story how it first came to be found. The story actually goes back to 2006. So Lee Hall, who I just saw a few minutes ago, he's now working here at Museum of the Rockies. Back then, he was, I think, an assistant crew chief or maybe a volunteer But he was out walking around prospecting, and he found a lower jaw, beautiful little lower jaw, denary, with some really cute little teeth in it. And he said, "Oh, very nice. It's a little alligator jaw." We find a lot of crocodilians in the Hell Creek, so it wasn't too out of the ordinary. But he put it into a paper bag, and he labeled it alligator jaw. And he named the site Chomper. Took GPS location, took all his proper notes and everything, collected good data, and then kind of forgot about it because there were other really cool, exciting things to find. An alligator jaw is fun, but it's not anything groundbreaking, especially not at this museum. There's so many cooler things that field crews would find, more important stuff. And so there it sat until, for years and years, just in a little brown paper bag in collections, labeled alligator jaw, until 2006 when Denver Fowler was going through collections. And he sees the little bag and he's like, "Oh, everybody loves alligator jaws. I'll open it up, have a look." And he goes, "Holy cow, this is a baby T-Rex jaw." And so the summer after that, he took me and some other crew members out to the site. We relocated it since Lee took good notes and everything, and we were able to find the site again. And sure enough, there are more pieces there of this baby T-Rex skull. And so, using that, we've got some pieces of the denary, we've got some pieces of the top of the skull. I think we might have some frontal bones, got a few other good spots. And Larry Whitmer and his crew were actually able to do like a 3D model and reconstruct what the rest of the skull would look like. This is based in part on closely related tyrannosaurs like Tarbosaurus, for whom we have really good juvenile skulls. So there's not as much guesswork here as you might imagine. But pretty awesome. Chomper Rex. One of the dinosaurs I helped dig up. It's an honor to see it on display here. Really neat. And just part of this wonderful growth series. Yeah. Maximus Midnight. I know, baby T-Rex, really cool, right? That's the thing, is that everybody, when they think about Tyrannosaurus, they picture this big hulking carnivore. That's what it's really well known for. But it didn't start off that way. They hatched out of an egg about this big. And, And they get, of course, progressively larger as they get older, but they undergo a lot more changes, too. So they start off, pretty lightly built, lightweight, pretty svelte. And, by the way, iios and laurdee just got back here.
Yeah. Welcome back.
How was your little break?
It was great.
It was great.
Good.
We needed a little snack.
What
Nice.
was needed.
Good, good.
And now I feel great.
I was just telling Chat about, do you know who this is?
Is this who you have at your house?
Yeah, that's Chomper Rex.
Chomper Rex.
Just the head, though? Yeah.
Yeah, well, I mean, we only actually found pieces of the skull.
And this is a 3D print of it, too.
This is a 3D print of it,
it's a great
from
looking
Larry
one.
Whitmer's lab at Ohio
It's been
University.
Prepared very nicely.
Yeah. So the one that I have is, I guess it's supposed to be slightly younger than Chomper Rex because it's smaller and it looks much less developed. For those of you who might be new, I've got a full-size juvenile Tyrannosaurus skeleton 3D print at home in my office. You'll see it if you tune into future streams once I get back home to Oakland. But it's based in part on this specimen. Really cool.
Do those little holes in their snout change as they mature as well, indicative of a different palate/diet?
I don't know, the little pits that you see in the denary and the maxilla. So yeah, those are like blood vessel grooves. Might be like sensory pits too. That's your alma mater? Ohio University? Yeah.
Small.
Very cool. Just like... But yeah. Larry Whitmer's got a very cool lab there in Ohio.
Conqueror says the skull gets a bit wider as it ages.
Absolutely, yes. You will see just how wide.
A lot wider.
Look at that right there, how narrow it is from side to side. This is kind of typical for a lot of theropod dinosaurs. It's kind of the primitive condition. But they do start to widen out a bit, and you'll see how wide they get toward the end. This is a specimen known as Jane. This is from the originals at the Burpee Museum in Illinois. This is once held by some paleontologists to be Nanotyrannus, like a weird small pygmy tyrannosaur dinosaur. It's also really strange that we don't have any juvenile T-Rex, but we've got this other smaller T-Rex looking thing. We're going to give it a different name. You know the story.
Is this Nanotyrannus?
Yeah, this was known as Nanotyrannus for a while.
Right.
Or some people considered it to be Nanotyrannus.
Ms. Strictine says, I gotta ask.
Yeah.
Lips?
Oh.
Question mark?
I don't know. I
get
get that
asked
question.
so often.
I get that question so often. I don't know why people are so obsessed with it. There's so many people argue over this, and I don't know. We'll figure it out, and I'm not too worried about it right now. Yeah. I don't know. I don't know. I don't have a horse in that fight. I'm not gonna get dragged into that conversation.
Frenchy Weasel, excuse me, wonders if you can tell the sex of the animal apart.
Yes and no. We have the world's only female Tyrannosaurus here in this museum, and I will show her to you in just a little bit, but we'll talk about it. The answer is mostly no. We can't actually tell dinosaurs apart, male from female, just from their skeletons externally, but there may be another way to do that.
Wow, this is
Anyway,
incredible. This is a cast. It's a replica.
Yeah,
Okay.
so this is a replica of, actually this is her right here, B-Rex, the world's first female non-avian dinosaur. I'll tell you the story in a little bit. It's really cool.
Sue is not a girl, says Tropical.
We don't know. We don't know whether Sue is male or female. Nobody's really tested that in a way that makes much sense. So yeah. So Sue, the T-Rex, was named after Susan Hendrickson, who was the discoverer of the specimen. This one here is known as B-Rex, and it was named after Bob Harmon. Bob starts with B, so B-Rex. For a while, Museum of the Rockies crews would find Tyrannosaurus specimens, and they'd call it B-Rex because Bob found it, or I-Rex because Irene found it, or something. I don't know. Yeah.
Maximus wonders what the tiny holes are in the upper jaw above the teeth.
Yeah, so that's still kind of debated right now. Some paleontologists think that these are blood vessel grooves that would have helped nourish fleshy lips that would cover most of the teeth. There's some paleontologists like Thomas Carr who argue that these are almost like sensory pits in a crocodile. So crocodiles will have they've got a really sensitive skin around the top of their teeth right there, on their jaws, and it helps them to detect moving prey in the water and that kind of thing. Maybe Tyrannosaurus had something similar. We don't really know. The jury's still out on this. We're not sure yet. But yeah, they're
For whiskers.
Whiskers.
You think they're for whiskers?
They're for whiskers.
Makes sense to me. But they do go all the way up, kind of. And there's even on the
Yeah.
up here and up above on the
Yeah, those are probably, I would think those are associated with the keratin that would be on the top of the head.
Well, then why not the same thing down here, right?
Maybe. That is one of the ideas, yeah. And also, if you look above, the lacrimal bone and up there, above the eye, it's all spongy and crungly. Coining new words here, left and right.
Crungly.
But that would have been a display feature right there. So that's a big, cranial boss. There probably would have been some really brightly colored skin and keratin on there, almost like on a shoe bill, not a shoe bill, excuse me, a hornbill. Yeah. So, and that's one of those things that changes in ontogeny. And young tyrannosaurs, they don't really have that. Got a little crest there, but it really starts to grow and change as they mature. So let's move along to right here. So here is MOR 980. This is the actual skull of that T-Rex up there. I told you that T-Rex, the skull was all artificial material because it was too heavy to mount on the skeleton, even though the rest of the bone, the dark brown stuff, is real. Here is the actual skull from this animal lying behind the skeleton. It's really cool, huh?
Really?
Yeah. It's got these little premaxillary teeth in the front. I was telling Chat earlier about how the different sized teeth on Tyrannosaurus probably had different purposes. So you've got smaller teeth in the front. These are used for nipping and biting little bits of flesh off of a carcass. And then these big teeth, big honking ones on the dentary and on the maxilla. Look how thick those are in cross-section. Those are for crushing and puncturing. And you might be able to see there are serrations on them too. There's little ridges on there. So they are still kind of good for cutting and slicing too, but these are mostly evolved
Yeah,
for...
it's almost like it's like a plastic knife.
Yeah.
It's worth of serration or something. You know?
Not super sharp or anything, but just enough
monsters.
to kind
We came
of
here to find
give you some
fossils.
cutting power. But yeah, these teeth are mostly evolved for just crushing. Yeah.
The dark part of this skeleton in particular, DK, is real.
Yeah. So all of the dark parts that you see here are the actual fossil bone.
Yep.
Anything that's tan is sculpted or maybe cast from other Tyrannosaurus. So yeah, it's very, very rare that we find a complete dinosaur, as you probably know. But yeah, really cool. And look how big and knobby those spots are above the eyes. Those display structures just getting bigger. And again, compare how wide this animal's skull is. Look how big and wide that is.
So
compared to these little guys over here. They start off very narrow and they just get progressively more and more robust. They're probably changing diets as well, going from predator to maybe like a pursuit predator into like an ambush predator, or even like scavenger part-time. Who knows? Yeah.
So as we are looking at an age progression like this, would the museum try to get dinosaurs all from the same age?
From the same rock layer?
Rock layer, that's what I'm trying to say.
It's a fantastic question. Yeah. The weird thing about this is that this looks like they're just getting progressively more mature. I think B-Rex actually might be the most mature out of all of these. She was the oldest when she died compared to all the rest of these. She's also the oldest stratigraphically, so she's from the very bottom of the Hell Creek Formation.
Oh, so she looks...
So she's going to look different from the rest of them. Even though she's not the biggest one here, she is the most mature, I think. It's kind of confusing, but again, when you're dealing with ontogeny and stratigraphy and anagenesis, stuff, there's a lot to keep track of, There's a lot to keep track of. So yeah. So yeah, great question, Laurdee. Here, continue along this way, and we'll look at the Wonkelrex right here. MOR 555. So the Tyrannosaurus specimen that we saw outside, that's this right here.
It's the same one. Right?
Same one. Yeah. It's big.
Yeah, and reading the plaque, I noticed that they had loaned it to the National Museum of Natural History
at the Smithsonian.
Yeah. For 50 years.
I was here for that actually. So it was like a big rigmarole. They had a big ceremony. They had a giant FedEx truck that came to cart it away.
And it's so interesting that the center line of this T-Rex's skull it's all long.
Yeah. So that's not
called. It's after it's dead. There's
taphonomy.
changed taphonomy.
There you go. Yeah. See.
I listen with the stream.
Yeah.
Very interesting,
So this one, I think the skull was found disarticulated, so some of the individual pieces got a little smushed. Anytime you've got a fossil, lying in the ground for 60 plus million years, it's going to get a little bit distorted there in the ground, especially when you've got a lot of earth on top of it. So that's the case here. It is a little bit wonky. Nobody's got perfect bilateral symmetry. Even our skulls are going to be a little bit different from side to side. But it gets amplified. So this, you can now see the original of this one at the Smithsonian in Washington, D.C. They've currently got it mounted hunched over a dead Triceratops, ripping the head off of it.
Oh my gosh, that's so cool.
Yeah, and it's research based on Denver Fowler's work.
Oh, okay.
Yeah. That display is based on his work, which is really cool. Yeah. So yeah, anyway, we used to have this one here on display. It used to be right there where Yoshi's trike is now. So T-Rex used to be the Wonkelrex, all laid out in the ground, just like it was in the field. And it was like a mock-up of what the dig site looked like back in the early 90s when they dug her up. And here's MOR 008. This is the Hager-Rex, I think it's called. Or maybe Custer-Rex?
Yeah, it's Custer.
Custer-Rex, okay, yeah. But yeah, this is the largest Tyrannosaurus skull in the world.
Wow.
Bigger than Sue's skull. So this presumably would have been a bigger Tyrannosaurus than Sue, from snout to tail. But I know, pretty impressive, right? Let's take a look from this angle. Look at that. And again, the brown parts are the actual fossil bone, and the tan parts are sculpted and filled in. Pretty cool.
How long is that largest head? It's hard to tell on stream.
It's approaching 5 feet long.
Hello, I'm Sam Neill
Yeah.
from Jurassic Park.
Yeah.
Let's protect our
It actually
fossils
literally
because
says measure.
if they're removed,
Does
America
it?
loses them.
There you go.
Forever.
It says one of the largest. Too modest. This is the largest Tyrannosaurus skull in the world that I know of. Pretty impressive. Yeah. Yeah. And look at those bosses above the eyes. Look how big and pronounced they get and how scrungy they are.
Scrunchy. I thought it was clungy.
I don't know.
Do you know which one is the newest Tyrannosaurus?
Newest, like the most recent?
Youngest. Not
Stratigraphically, like rock layers?
Yes.
Yeah. I think it would probably be... It might be this guy here. It might be... I actually don't know the stratigraphy on 008.
Yeah.
But I want to say he's pretty young stratigraphically. Probably from pretty near the boundary. Yeah. I know that the Wonko-Rex is pretty old and B-Rex is really, really old stratigraphically. Yeah.
Stunning. Yeah.
Really amazing stuff.
Let's see, what else do we want to look at over here? I've seen most of the stuff in here. I'll tell you the story of B-Rex. Yes. So there's actually a 60 Minutes piece from CBS. Like the 60 Minutes, like the news magazine show. It's called 60 Minutes Presents B-Rex. This is the skull right here of B-Rex. But this specimen has one of the coolest stories here in this museum. Here is one of her metatarsals right there. And, and that one was removed for research. It'd be cool to be able to show you, but I guess it's exciting that it's been removed, currently being worked on. Yeah. So, way back in, this would have been pretty early on, like early 2000s, maybe like 2001 or 2000. There's a great big crew working in the Hell Creek Formation. This is like the beginning of the Hell Creek Project. So Jack Horner got a bunch of money from like Discovery Channel and like the Smithsonian and stuff like that. So he had some pretty huge crews. And Bob Harmon, who is he's like chief preparator and like lab manager here, I think. Anyway, Bob Harmon is like all around, how do I describe him? If you've seen the movie Once Upon a Time in Hollywood, Brad Pitt's character in that movie totally reminds me of Bob Harmon. Anyway. Jack Horner actually discovered Bob Harmon way back in the day. They were like both out in the field at the same time, and they saw each other like across a gully, and they like stalked over to each other, and they were just like, "What are you doing here?" And Jack said he was like genuinely intimidated because Bob had a pretty serious looking gun on his hip. But yeah, Jack went out that day looking for Tyrannosaurs. He found Bob Harmon instead, and that turned out to be a much more fortuitous discovery because Bob later went on to find stuff like this. So at one point, Bob Harmon went out for a walk, like in the middle of the day, and I think he sat down to eat lunch, and he saw at the base of a 50-foot cliff a little bit of Tyrannosaurus metatarsal sticking out. And actually, that's this right here. You see how this is all kind of a white color right there? That's because it had been sun bleached. Been sitting there for I don't know how many months or years at the base of this cliff, and he knew just instantly it was a Tyrannosaurus metatarsal. And it was at the base of this really tall cliff. But because it was at the base of the cliff, it was going to be really important stratigraphically. This is from the very bottom of the Hell Creek Formation. So this would be maybe the world's oldest Tyrannosaurus specimen. So yeah, he knew he wanted to dig it up, but it was in a pretty precarious place. So what Bob did is that immediately, without even like consulting anybody, he went back to camp and got a folding chair, brought it back to the site, and he stacked up a bunch of rocks here. This photo doesn't really do it justice, but this is the sheer cliff right here. I don't know how high up the cliff he is, but yeah, he's on a folding chair with a bunch of rocks stacked up right there, and he is digging away at this, trying to uncover more of this metatarsal. And it turns out it kept going. There was more and more of it there, and there's a pretty good chance it was going to be a whole skeleton, or at least, enough of an associated skeleton that it would be worth it to dig it all out. And so for the next 3 summers, they just worked on knocking down this whole cliff They had whole crews of people with climbing gear, like rappelling down the side with jackhammers, and they just knocked down this whole cliff in order to get down to the bone layer. It was quite the undertaking. And, yeah, oh, there's Liz right there. Talked about Liz a lot. I think this is one of her first years at MOR. It's Dr. Liz Friedman-Fowler. I've done a lot of work with her. Anyway, they finally get down to the bone layer and they're excavating this specimen, but it's in such a remote place that they can't, like, carry out some of the heavier jackets by hand. They had to call in a helicopter to do it. And one of the jackets that had one of the biggest bones in it, the femur, was too heavy for the helicopter to lift. And so they actually had to, like King Solomon, they had to cut the baby in half. And it turned out to be a really lovely thing, because there were some pieces of that, like, you know, kind of spilled out as they were cutting it. And I think Jack Horner thought, well, I'll kind of take these pieces and I'll ship them to one of my students who's working on, like, the interior of dinosaur bones. Mary Schweitzer right here. And yeah, so she had taken some of these pieces and then started to study them under the microscope. Well, the first thing that she did actually is that she was just looking at them and, like, found a weird bit of tissue inside, all fossilized. And this is in the 60 Minutes piece. She goes, "Oh my God, it's a girl, and it's pregnant." It had what seems to be a row of medullary tissue, like a little layer on the interior of the bone. This is the same sort of tissue that birds lay down when they're ovulating, when they're about to lay their eggs. You know, bird eggshell is made of calcium. And so that calcium is taken from the rest of the body and kind of stored temporarily in the medullary cavity of long bones like the femur. So if you find medullary tissue in there, that means this bird is about to lay eggs. Turns out tyrannosaurs are the same way. And so B-Rex ended up being the world's first female dinosaur. It's the first time anybody's been able to definitively say if a dinosaur was male or female. So there you go. And then later, almost maybe even more exciting, you have Mary decides to dissolve some of these bones in acid to try and get rid of some of the minerals. But she accidentally used too much acid. All of the mineral dissolved away, but there was stuff left, like organic material, it seemed, from the animal. And so to see how this relates to, you know, dinosaur paleobiology and maybe the prospect of bringing dinosaurs back from extinction, you should check out that 60 Minutes video. Yeah, it's really, really cool. We watched it a few times on my channel before. Maybe we'll watch it again soon. But it's called 60 Minutes Presents B-Rex, and it's a really cool story. So yeah. How are we feeling over here? Are we good? Want to wrap things up pretty soon?
I was going to suggest that when you're done in here, maybe we go sit outside for a few minutes, wrap things up, answer a few questions.
Yeah, that sounds great. We'll go see the Wonko Rex skeleton out there.
Get your pennies.
Yeah, I got to get my pressed pennies too. Yeah, you still have the pennies in here? Oh, you gave them to me.
I haven't even heard about Danny's pressed penny collection chat, so...
Yeah,
you know.
it's part of this big road trip. Yeah, I'll show you a few more displays in here, and then we'll kind of backtrack through the fossil hall, and we will go outside and I'll show you the big bronze Tyrannosaurus skeleton.
So T-Rex is just a giant wingless chicken. I think that's an oversimplification.
It is an oversimplification. Think of it, T-Rex was first. So chickens are tiny, feathery, toothless theropods. Yeah, like T-Rex. Here, we've got a nice sample platter. We've seen a lot of these from the Hell Creek Formation. All these different critters. Thescelosaurus pelvis. There's a big bowfin fish, vertebral centrum. We still have bowfin alive today. And then there's a gar scale from a critter like an alligator gar. Another fish that's still around today too. Gives you some sense for what this environment was like. What are the environments that you find bowfin and gar? Kind of swampy habitats, you know, slow-moving rivers and swamps and ponds and stuff like that. The Hell Creek Formation represents an environment much the same as that in a lot of places. Yeah, turtle femur. What a weird-looking bone. That's a femur from a turtle. Phalanx from an Edmontosaurus. Crocodile skull bone. All kinds of cool stuff. So
Yeah, there's an epi from a Triceratops. This is one of those pointy bones from around the throat. You can tell by how pointy it is. This is like a subadult animal, maybe even younger. And this is super important and exciting. For a long time, paleontologists asked why we never found baby dinosaurs in the Hell Creek. It's like, oh, well, they must have had their babies elsewhere. They didn't lay eggs in the Hell Creek area. We just didn't have baby dinosaurs in the Hell Creek. Turns out they just weren't looking hard enough. They are there. And we've got pieces of them here in the Hell Creek, including a beautiful baby Edmontosaurus skeleton right there. So they're there. There might be some size sorting stuff in the Hell Creek where like you just don't find as much baby dinosaur material, but the stuff is there if you look hard enough. So pretty cool. Ooh. I'm glad they finally fixed this display too. This used to be spelled wrong. This is Montanoceratops, which is a little like leptoceratopsid dinosaur from the St. Mary River Formation, which I think is equivalent in age to the Hell Creek. But yeah, very, very cool. You can see there's the jaw right there in part of the skull. There's the dentary. Yeah, articular process, and a scapula and some ribs. And then it must be that femur right there was found first. Maybe part of it eroded away, because you see how that's lighter colored than the rest of it? That was probably sitting there in the sun for I don't know how long. And all the rest of the bone was underneath and retained its dark color like that. Yeah, pretty neat. There's a hand, and there's
Really
a foot. I know, right?
vertebrae. Yeah. They're in great condition.
Yeah. There's a lot of glue that went into those too. You can see a lot of the breaks that have been fixed.
Oh, yeah.
Yeah. Pretty cool, huh?
That actually sounds like a really fun job to me.
Yeah? You think you'd enjoy it?
To put back together those tiny things.
Yeah, it's like a puzzle, but I don't know. But you don't have a picture to work from, and
Right.
The pieces don't fit together exactly. You got to glue them. Yeah. Yeah. Over here we've got some plants from the Hell Creek. Really, really important. I know nothing about plants, but I just know how important they are.
Why did they leave some dinos in the rock and take others out?
Good question, Peculiar Princess.
That's a great question, yeah. In this case, it actually was taken out of the rock. So here, it was put on display with like fake rock underneath to give you a sense for what it may have looked like in the field, maybe. But yeah, the thing is, it's really, really expensive to make a mounted dinosaur skeleton. To like come up to like weld together all of the metal that's necessary to make a skeleton stand up. So oftentimes it's much cheaper and quicker and simpler to just kind of put it on its side like that with some fake rock underneath. But sometimes all you want to do is kind of expose the surface of the rock as well, and like of the fossil as well, and kind of leave the rest of it in situ. It's just safer that way. You don't risk damaging it. And with new techniques like CT scanning and stuff like that, you don't always have to excavate everything all the way. You can still just scan the whole thing and get all of the surface detail and even some of the internal information without having to actually remove it from the rock completely.
This is Champsosaurus.
Oh yeah, we've got some Champsosaurus stuff. Yeah.
Champsosaurus is a name I've heard before.
It is? Yeah, Champsosaur vertebrae.
Crocodile, right?
It wants to be a crocodile, but it's not. So this is like a really weird lizardy animal. We used to have a skeleton of it over here. I wonder if it's still there. They moved. No, here it is. It's over here, I think. Maybe that's actually a crocodilian. Okay, yeah. So this is an alligatorid, Borealisuchus. This is one of the crocodilians we have from the Hell Creek. See that really cool texture that they've got on their armor scutes? On their skull? Modern crocodiles have the same thing.
Oh.
Yeah. Anytime you find crocodile scutes in the field, you like instantly know what you've got. It's just unmistakable. That really unique texture. But this is a Champsosaur skull right here. So it says aquatic lizard there. I think these are squamates. But this is basically a big, weird aquatic lizard that really badly wants to be a crocodile. It's doing the same kind of ecological job as a crocodilian. It's got these long, spindly jaws, most likely used for snapping at fish.
That turtle shell is so cool.
Isn't that neat?
Actually,
Yeah. Trionychid turtle. Man, one of my first jobs at UCMP was labeling and sorting Trionychid turtle shell. It was like thousands and thousands of pieces of shells like this, just numbering each one individually with a specimen number and locality number.
And this seems like a very complete soft-shelled turtle.
Yeah, pretty nice, right?
How old are these specimens? Can you?
So these are from the Hell Creek.
Yeah.
Yeah. So that's between 68 and 66 million years old. Yeah.
And is that stone on the inside of the shell that they left in place? Then okay.
Yeah. They didn't want to prep it out because I guess it just kind of holds everything together.
Definitely.
So yeah. Turtles. So the Hell Creek Formation is like the heyday of the turtles. I think that might be like chief turtle biodiversity is during the Hell Creek. There's like 22 species of turtle that lived in Hell Creek times. I don't think they've ever been more diverse than that in any one place. And all of them survive the KPG extinction event, the asteroid impact and all that, except for one. It's the great big turtle that lived on land. It's basically like a tortoise. That's the only one that doesn't make it across the boundary. So again, it fits this pattern of like big animals all going extinct, but littler animals, like turtles, surviving across the boundary.
Javasaurus wonders if it's a Rauisuchian relative.
If Champsosaurs are Rawasuchian relatives? No, Rawasuchians are closer to like actual crocodiles, like those guys. So yeah, these guys would be Rawasuchian relatives, but not Champsosaurs. These guys.
But the paleontologist field isn't narrow to what we understand.
I have like a full one to
On the
show
contrary,
you.
we stretch our understanding to try and take in the universe.
This might have been better off if turtles had stayed in power. You're not wrong.
Agreed. Yeah.
You're not wrong.
Yeah, and look at those vertebrae right there. In the Hell Creek, you will find just all over the place. You'll find gar scales, you'll find crocodile scutes, and you'll find Champsosaur vertebrae. They've got this very distinctive shape to them. There's kind of like an hourglass kind of shape on them. Their vertebral centra are really distinctive. So yeah. You doing okay? Okay. You ready to leave in just a little bit?
Well,
Okay.
We're done.
Okay. Well, no, we'll take a quick look at the mammals, but we'll turn around. I'm not going to focus on mammals today. This is all new in here.
I know, the museum actually has so many cool exhibits.
You want to go see some other stuff?
Not today.
Oh, okay. Yeah, Paleocene. This is right after the extinction of the dinosaurs.
Right.
You just have a few cool animals left over like Champsosaurs, but mostly everything's just tiny little sniveling mammals.
SMH in my age.
Yeah.
Did dinosaurs shake their heads?
Of course. Yeah.
What's this guy?
Well, it's a mammoth. Yeah. I think this is a Colombian mammoth.
So, Anne just asks if the Hell Creek is a protected place.
There are certain places that are protected, like federal land and state land, but it's not like a national park or anything like that. There's Hell Creek State Park, but it only has like a few. It's got a bit of fossiliferous rock in there. It's mostly like a recreational area with like boats and RVs and stuff.
Is this teeth?
Yeah, those are teeth.
Real dinosaur?
Yeah. Mammoth teeth. Yeah, right? They've got pretty flat teeth, like modern elephants. That's how you can tell the difference between mammoths and mastodons at a glance. Mastodons have teeth that look like our molars, big cusps on them. And mammoth teeth, like that, look like that, all flat underneath.
And the tusk inside almost looks like keratin, I guess, but it looks like almost.
So that's a tooth.
Right. Yeah.
Yeah, a tusk is an elephant tusk is a tooth.
Right.
Yeah. Very cool. A big head.
I think I didn't ask you this. Never mind.
Yeah. Here's a Gomphothere right over here. So this is a smaller proboscidean, smaller elephant, and look at that's the lower jaw right there. And see the teeth look almost kind of like human molars, similar to like mastodon teeth.
Yeah.
But look at the tusks coming out of the end of the jaw. It's like sticking out of the chin, basically.
Yeah.
Really weird, huh?
Just like a single.
It's
a unicorn. It's a unicorn. It's like a unicorn, except if it was like, I don't know.
Yeah. If a unicorn were an elephant and also Jay Leno.
Unicorn with a chin horn. Tooth beard, exactly, pennies.
Elephants do some really weird and cool
I
things.
was asked if Hell Creek was a protected place. Did I ask you that?
Yeah.
I'm
yeah.
sorry. Okay. My memory is
There's a lot of federal land in that. So Hell Creek is not like. There's an actual creek called Hell Creek. There's Hell Creek State Park, which is right nearby. And then there's the Hell Creek Formation, which is like all of these rocks from that part of the Age of Dinosaurs. All like one big set of depositional settings. Oh, before we leave the Hall of Horns and Teeth, let's say hello to Yoshi's Strike one more time. Even mounted incorrectly, I still love Yoshi's Strike.
It's almost like it's all up on.
Yeah, it's all wrong.
It's like it's doing like a cat-cow, you know?
Yeah. It's all wrong.
Curious.
Yeah. Oh, but here, let me show you also, we didn't look at this yet. The occipital condyle on this. Here. Is you're looking up at the back of a Triceratops skull. So like the frill would be way up there, like that. And then you can actually see there's bits of the upper jaw right there with the teeth. And what do you think that big ball thing is?
Yeah, it's like a socket, or it fits into a socket.
Yeah, that is the occipital condyle. So that's like the big trailer ball, basically, that the head is attached to. Look at how big that is.
That's huge.
Just a solid ball of bone. It gives you some sense for how big and heavy these guys' heads were. Just amazing. Yeah. And we've got...
a big old jawbreaker there.
Yeah, like... Yeah.
But the paleontologist field isn't narrow to what we understand.
Crazy. We've got
on the
occipital
contrary, we
condyles from
stretch our
Triceratops
understanding to try and
with,
take
all
in the
these little
universe.
Delicate scrape marks on them. We're trying to figure out, like, what is that? You know what it turned out to be?
What?
Bite marks from the little premaxillary teeth of a Tyrannosaurus.
Ah.
So just like these dainty little scrape marks from the little teeth in the front of a T-Rex's mouth. Really cool stuff. We are now working on exiting the museum so I can show you the big Tyrannosaurus skeleton out front and get our pressed pennies too. Yeah.
Why did mammals take over after the extinction as opposed to other small animals? By how you describe them, mammals seem inferior in every aspect.
I know, I'm really tough on mammals. I'm sorry, mammals. Some of my... I don't know. I guess they were just kind of like... They had some potential and they were just particularly kept down by dinosaurs, but... Mammals had already diversified a lot, but they just hadn't gotten big and hadn't really done anything interesting. I'm not sure why they won out instead of, like, crocodilians or lizards or... You know, why did those creatures not become, like, the big, dominant terrestrial animals? I'm not sure. Yeah. Anyway, we're now going through this tunnel. There we go. And, yeah. So, yeah, let's get some pressed pennies real quick, and then we'll go sit outside. Yeah. Here we are. So this has been a big part of this trip so far. I collected some of these when I was a kid, but I've really made a big deal out of
We
it.
need to have Danny put the pennies into the machine.
Oh, yeah,
or
yeah.
It's just not right.
Well, I've got them right here.
I think Laura has them. She's saying.
You've got some additional ones?
Yeah.
Okay. I think I have... Oops. Hopefully I didn't nudge the camera too much. Here we go. Okay, so, I don't know if you know, if you're familiar with the old U.S. penny into a little souvenir right there.
Yes,
And
legal. Wow, the U.S. code even covers this.
apparently, like, if they really wanted to go after you for this, they probably could, but, yeah, anyway.
Yeah, it's down there. Magical.
Very cool. Check that out. I'm going to make another one just like this. Let's see. I think I have... Yeah, I got the quarters.
Maximus says the ones he's done are all manual.
Yeah. There's a lot of manual ones out there, too.
This is the real content.
Oh, yeah.
The pressed penny content. Yeah.
Yeah, this is what you came to paleontologizing for, right? You get these. Yeah, you go ahead and push it in.
Here we go. There you go.
Very
Comes
cool.
out just like that.
Very, very cool. Do you want to do one more?
Sure.
Okay.
Heck yeah. About going a mile a minute here. It's
been
like,
saving up all year for this.
Like I think Patchwork said, or maybe it was Reno said, 51-cent souvenir. Yeah.
Yeah.
There you go.
Well, it's like my Uncle Russ always used to say, you know, a penny saved is a penny earned, but a penny squished is 51 cents.
Oh. What fun relatives you have.
Yeah. Very cool.
Yeah. Nice and hot, too.
Yeah. All that squashing really...
Shalia wonders how many $1 million of pennies have been smooshed by that machine.
Probably a few.
Sounds like a
I
good
might get
interview
one
question.
more at the other machine right there, too. Let's see. May I please have 50 more cents, laurdee? Thank you. These are my quarters. I brought them. Yeah. Can I have 50 cents for something I need?
Well, if it's for something you need.
All right, this one does not have a Tyrannosaurus skeleton on it, but we're going to get it anyway.
It's got a buffalo. Bison.
Yeah.
Word.
You can call it buffalo if you want.
Totally word.
Yeah. Yeah. But yeah. All right. Oh, wait. Other people are going to use it right now. We will let them do that, and we will go outside and go hang out under the Wonko-Rex bronze skeleton. Don't want to monopolize that machine too much. But check this out. This is one of those, I would argue, the coolest landmark in the city of Bozeman is right here. Check this out.
It's huge.
Yeah. So this is MOR 555. This is the Wonko-Rex. You'll actually recognize this from chat. The yes emote is this specimen right here. Yeah. And the like chomping tyrannosaur jaws and the stream starting soon thing. That's this specimen. Yeah. MOR 555 cast in bronze. It's beautiful. So I lived here in Bozeman for about 8 years. And I made a habit of, I don't know, sometimes late at night I'd go for just go walk over to the Tyrannosaur, like sit under its metatarsals, my back leaning up against them, look through the rib cage up at the stars, just think about what it all means, you know?
What does it all mean, then?
Well, we're figuring it out.
Oh, okay.
It's got a lot to do with dinosaurs.
Yeah. Yeah. I mean, you know, it makes sense.
I don't know. Maybe my musings were colored by my surroundings at the time, but yeah, I think it's got a lot.
Setting, Danny. It's what they call it.
I think it's got a lot to do with dinosaurs.
Set and setting.
Yeah. But yeah. There's a family taking a picture under it right now, but we'll go over when they're done.
Yeah, we don't want to be creepers or intrusive on anybody. It's a very important part of streaming.
Exactly. Yeah.
Not to make anyone uncomfortable.
Just don't be obnoxious. You
Rule
know?
number 2.
But yeah. Very cool.
Yeah, it's not too bad, honestly, Patchwork. The smoke isn't that bad. Honestly, it doesn't.
It's
really
gotten a lot
smell
better.
smoky.
Yeah. I mean, holy cow! You can see the bridgers now. You
Yeah.
couldn't see them when we got here.
Yeah, the mountains are finally kind of coming.
So yeah, the Wonko-Rex right here. Again, just gives you a sense of scale with this whole animal. We will see this same specimen at Berkeley, at UCMP. It's the same specimen there in the Valley Life Sciences building. And you can see the original at the Smithsonian. We gave it to them on, a 50-year loan. in Washington,
because
D.C.
they no longer knew how to love each other.
Yeah, it just gives you...
That's
This
correct.
is bronze, yeah. Yeah, it's hollow.
Exactly.
It's not solid
And I
bronze.
certainly wouldn't want our species
But,
dead the same way.
It's beautiful, though, right? I mean, holy cow, and the pose is just lovely.
Yo, hey, John Ming, thanks for the tier 1.
Yeah.
Or thanks for the 9 months, I should say.
Oh, holy cow. Thank you very much. Appreciate it. Yeah. Yeah, but this is my spot. This is where I would sit. Right down here. I read many a book late at night if I couldn't sleep or whatever. Just walked here from my apartment and just look up through there at the stars. Yeah. Spent a lot of time under here.
Yeah, thanks, Dravosaurus. Thanks, everybody. It's nice. I'm glad you all have enjoyed it.
Yeah.
It's been a lot of fun. We have more museum streams coming up tomorrow.
Oh, yeah.
But the paleontologist field isn't narrow to what we understand. On the contrary, we stretch our understanding to try and take in the universe.
Yeah.
let's do it.
It's a
Yeah.
much smaller
Plan.
museum. Much smaller.
So maybe not 4 hours of mind-blowing artifacts.
No, but it'll be fun.
from
You'll
our
have a lot
natural
more to talk about there. It's going to be...
Yeah.
Yeah.
I think a large section of the paleontologizing audience will find it interesting. Probably.
Okay.
Probably, but we'll probably, but
figure it out.
probably.
Yeah.
For real.
Yeah.
Do you want to just sit on the bench here and you can...
I think that's a great idea. Set up the tripod here.
Just for a moment.
Yeah. Let's
There
see.
are some ants on here, so-
Hang tight, everybody. Big ants, yeah.
You drive up I-15, honk. Aw, thanks, Lenina. I'm glad you've enjoyed them.
Here we go.
Danny
Deploying
had a
tripod.
hammock that was permanently hung under the jaw and covered boot.
Pubic boot. Who said that? Come on, load. Oh, we had a bad load. Come on. The font's all wrong. Didn't load properly.
We're back. Whoa.
All right, we're back on.
Oh my god. We're not saying anything. Hey everybody, welcome.
We're all staring at our phones.
We're
Hey,
in the same
everybody.
place. We haven't
Oh
gone
my gosh,
anywhere.
we haven't gone anywhere. Hey everybody.
Hold up,
No
we were not
sound.
talking for a second. Do we really still have no sound?
Oh,
now?
no sound.
We'll see for a second. We'll see if people keep saying they have no sound.
The rocker was turned all the way down.
Okay, great.
Okay.
Smart.
Yeah.
So let us know in
Rocker
chat if
turned
you
all the
can
way
hear
down.
if you can hear us now.
Nice. For some reason, my chat,
They
it's
can
all
hear us.
the messages are all doubled up. Why is it doing that?
My
You
gosh,
should
thank you
contact
guys
the
for
app
hanging
author
out and
complain,
staying
file a
with
bug
us.
report there, Danny.
It only does it after it goes online and goes offline and back on.
It's doubled.
Uh-huh.
Maybe if we could do it more and it would have like
If I
3
force
messages.
stop it, I bet you it'll. Let's
Thank
see.
you guys for being here.
Thank you all for staying
Thank you
with
for
us.
sticking around with us. You are the real champions here. Thank you so
Yes,
much.
definitely.
For real.
Yeah. Holy cow. Well, we got it back up and running. Yeah.
Yeah, we just, it's good to experiment. We need to learn how to come back up after it goes down. And anyway, everyone else is gone. Literally, everyone else in the parking lot.
Parking lot's empty.
Basically
Can
empty.
I risk?
If you want to. It's your
You're gonna
stream.
have to at some point, yeah.
Yeah. So look, parking lot empty. Museum might even be closed right now. I'm not actually sure.
Yeah, it
but
may have closed up.
yeah. But yeah. Anywho.
Dinosaur says all that to say goodbye.
All that to say goodbye. You know, we're not doing the Irish goodbyes. It's not our style. On the Twitch.tv.
Well, we want to be able to reproduce what went wrong with the camera, and so far our working hypothesis is
Nothing. I have no idea.
Gremlins.
Randomness. Cosmic rays is a decent hypothesis.
You're talking to somebody who does this sort of thing for a living, sussing out problems and figuring out what went wrong with the technology. And
we're currently on the original cable that we swapped away from. All this tells me is nothing. End of list. No, wait. It tells me nothing, actually. It tells me that the live view is uncooperative.
I could have told you that.
Which Danny has been telling me, and I've been like...
No, you've been...
User error. I
no, it's cursed.
I'm
cursed.
sitting here and I'm like, give up, Danny. Give up. It's time to give up, okay? It's time to end stream, Danny. He's like, 3 more tries, okay? 3 more tries.
Yeah.
All for you, chat.
Unreal.
All for you.
All for you,
Unreal.
chat. Yeah, holy cow.
For real. Worth, though.
Well, what was everybody's favorite part of the museum, first off?
Yeah. Well, let's start with you. You asked the question.
we had kind of talked about how our favorite part was that you were there.
Yeah, that was a question I got from chat.
But it's
yeah.
really, it's that you were able to bring everything to life.
Yeah?
Yeah. In such a way that just reading the placards you can. But what was my favorite exhibit, actually? Probably seeing the age progression of the Triceratops.
I was going to say that. I agree.
Yeah. Triceratops growth series?
Yeah, that was really cool. And it was so extensive, and they just get so huge.
This is the only museum in the world that I know of that has that.
Yeah, and then they did it again with the T-Rex, which I thought was cool.
Yeah.
Yeah.
Growth series, ontogeny. This is what I keep telling you about, chat. This is exactly, this is why I was so excited to show you this museum.
And what about y'all in chat? Let us know if you had a favorite part, what your favorite part was as chat.
Dare we pick up the bag and sit right there and have it? Okay. Let's see if we can get this set up.
And if it dies, should we have a if it dies speech?
Okay, yeah. Well, if this doesn't work,
like the Apollo, failure.
That's grim. If this cuts out, that will be the end of the stream, I think. So don't stick around. But we're gonna try and put the camera right over there, so we've got the Wonko Rex right behind us. We'll sit down on the grass. Are you okay sitting on the grass right there in the shade?
Definitely.
Okay. All right. So cross your fingers, everybody. Hopefully this works. Yeah.
Javasaurus says, well, for me, the newest thing that I liked was the burrowing dinosaur and how they figured it out.
Yeah, Eryctodromius, really cool. Really, really neat animal. Tilt this up.
All right, we should say goodbye on a high note.
Well, let's hang out for a few minutes. Give people a reason. Yeah.
It should be.
Still on, right?
Yep, video and audio are back.
Okay.
Really, the answer to most of life's technical problems is just to try it again, but then be very careful, whatever you're doing right now.
I'm just gonna put this on top. Give me something else heavy that I can do. The water bottle, maybe. There we go.
Okay, great.
Are we still live?
Yes.
Oh, okay. Let's see. Hi, Claire. Hi, everybody else. Ios, why don't you come join us? So,
I will.
It was just... Okay.
You're good.
This thing is a whole barrel of problems. I don't know if I could really recommend anybody purchase it. But, yeah. Live view solo. We've had the worst luck with this thing.
Really great.
Yeah. All right. So we'll just hang out with you for a minute, not touch any of this setup at all.
Don't touch it. Don't touch anything.
Just, yeah. And, yeah.
That's my reaction. Somebody's like, something's broken. I'm like, did you touch it? Why did you touch it? Did you need to use it? Are you sure? Can I undermine your assumptions about why you needed to do the thing you did and not fix your problem?
Mikey Legs, thank you for the 4 months.
Thank you so much, Mikey Legs. Really appreciate that. 4 months of support.
Hi, everybody.
That's awesome. Really appreciate you.
And thanks to everybody else who subbed today that we didn't get to say thank you to.
Seriously.
I tried to hit everybody up in chat, but...
Thank you for that. I saw you were very busy on your phone. I'm like, there's laurdee on her phone.
I know. I
being
felt
so
a little
diligent
bad.
about thanking everybody in chat and just being wonderful overall.
We're the nerds in the museum on our phones.
On our phones, following someone
Very
around with a
important,
camera, both on our phones. Yeah.
Thank you so much for being my referees and hype women and everything else.
Yeah,
no problem.
That was a load of fun.
It was really
Good.
fun.
I'm
Learned
glad
a
you liked
ton.
that.
Really enjoyed it.
And honestly,
museum's super chill.
I've never
I liked
seen
it
the
a
museum that crowded too. I'm never here during the summers. Like in the 8 years that I lived in Bozeman, I only visited the museum a couple times during the summer because I was always in the field digging up things to put in the museum. So, yeah, it's odd to see it full of people. I'm used to it being empty during the winter. So, yeah, but that was really neat. Everybody in chat who was here, what were your favorite parts? I'd love to hear that if you wouldn't mind sharing. Yeah. Ios and Laurdee said
it's absolutely. I don't know. It very well could be Shogun. Anyway, it very well could be. Yes, but people should talk about what they liked from the museum.
Yeah,
I think people might have said already.
You two both said that you really liked the Triceratops ontogeny display, the growth series of Triceratops.
I also liked the the pre-dinosaur displays.
Yeah.
Where they were kind of
The dioramas?
suspended. Yeah. I like dioramas.
You like
generally.
dioramas?
Yeah.
Nice. Yeah. Well, lucky for you, I might be working on a great big diorama in the fall. We'll have to
fun.
see. But yeah.
Lenina's favorite part was the whole thing.
Ah,
Great.
that's a good answer.
Javasaur
Yeah.
said the newest thing that you liked is the burrowing dinosaur. I think we
Oh yeah, Arictodromeus. That's super cool. Yeah.
RB liked the Triceratops growth.
Uh-huh.
Optic Nerd was just happy to be here to learn.
Aw.
We are, close to the business end of a T-Rex. Wrote down at one point we were.
Avatar says, museum? Oh, that thing I fill with dinosaurs? Exactly, yes.
Peculiar Princess says I like the turtle shell.
Oh, very
I really
cool.
like the turtle shell tool.
This is
too.
very
That was really cool.
the giant ammonite.
Yes.
Oh, you like Placentaceras, giant ammonite?
Mm-hmm.
Yeah, that's very cool.
That
very
brilliant
pretty.
red color.
That mother of pearl, yeah. Yeah, gorgeous.
Yeah, a lot of,
What would my favorite thing be? I think I'm always most excited to show off. I'm tempted to say Yoshi Strike.
Yeah.
But Yoshi's Strike... Oh, look, there's a magpie over there who's chasing around a bug in the air.
Nice.
Yeah,
Got
it's
it.
the black and white bird, yeah.
Yeah. I would turn the camera and show you, but we'd lose the stream again, I'm sure.
I know.
Yeah.
This is for a mobile live stream.
But it would take us 30 more minutes before we could do anything else.
Yeah. Well, you two had a wonderful idea. You're like, why don't we just hang outside the museum for a little bit? So, like, if anybody wanted to sub or anything and didn't want to interrupt, it'd be a good time to do that. So, if you've been thinking about that, now is your chance before it cuts out again.
You may never again get this opportunity to support the Paleontologizing channel. Don't miss out on this special offer. $4.99.
But yeah. Anyway,
starting at $4.99. I liked seeing the Triceratops you personally dug up. I appreciated your pride. It was cool.
Thank you, Avatar. Yeah, that was. I would love to. Honestly, what I would love to do is to get access to those molds and make a new cast and like mount it properly. Because the fossils themselves, the bones are beautiful. It just needs to be put up properly, Yeah.
Executive Storm says the best part is I can sit in my chair for 4.5 hours and it feels like only 20 minutes go by.
Oh, Executive Storm. Thank you. That is high praise.
I hope you're hydrating and you're going to get food for yourself too, because that's a long time to sit in a chair. Executive Storm. Listen to your body. That's too much dinosaurs.
Yeah. This is like, is that the new M. Night Shyamalan movie or whatever? I don't want to spoil it. Who cares? I don't know. Paleontologizing stream is like that, where it's the beach that makes you old, or whatever. It's like you sit here on the stream and you're 20 million years older and you didn't realize it. Seems like an hour.
Tripping through time, man.
Yeah. Scale model Javasaurs. Hey, I would love to do that. Actually, a long time ago, I worked on sculpting a Yoshi Strike skull. Yeah. I don't know. If I had a ladder and if I could climb behind the railing there, I could photogrammetrize the skull and then print it later. But yeah, I couldn't print it full size.
Mm-hmm.
That'd be bigger than my office almost. Yeah.
I reckon.
I'm excited for the computer museum tomorrow.
Wow. Yeah,
we are going to assume that everything's going to work.
Fingers crossed, hopefully. I don't know, this thing always seems to work.
It seems to work fresh.
We'll see.
Work fresh, yeah. But after you've been using it for a while, it's just like,
There's
no more.
less than the third of working with tech. Always assume it'll work. And then feign disgust and shock when it doesn't. Yes, this teaches the technology that you have high expectations for it.
Yeah.
So we're going to be doing a great stream tomorrow. It'll be fun.
Looking forward to it.
I look forward. I hope we see you there.
That should be cool. It should be a replica of the Antikythera mechanism. They have
super cool.
an old Commodore 64, which...
Not as cool, but still pretty.
They only ever built 64 of them, right?
No, there were far more. There were
sorry, that's the Nintendo 64.
2 to the 64 of them, or something like that.
Yeah.
Who can remember?
The Nintendo 64 was really it's really famous because they only built 64 of them, right?
We'll find out tomorrow at the Computer Museum.
Yeah, yeah.
We should raid somebody, is my suggestion.
We should raid
That's
somebody.
a great idea.
But we should raid somebody.
Whom shall we raid?
With all of you lovely folks who have stayed with us here, all 77 of you, my
I
gosh.
think you can direct the raid as an executor on this channel or whatever you're called.
Okay, great. Let's take a
Admin.
gander.
Who have we got? They cost 64 bits, says RB42. Okay. Oh, Rocket Sage is online? Okay. Who else have we got?
That's a good candidate.
Yeah?
I just have food and drink
scroll down.
streamers.
We raided Rocket Sage just a little while ago.
Yes, give me a moment.
No, here, I can go through my people I follow.
Yeah, check out your people. Because I just have food and drink streamers.
Following.
Our friend White Smoke is online.
Marine Mammal Rescue.
That's a great one. Chef Nagin is online.
Should we do Marine Mammal Rescue?
Yeah, it's very top.
Yeah, that's a chill one.
Place to go, honestly.
They don't need the raid, but you know.
That's alright.
Yeah.
I do feel like that's a good option here.
Yeah.
If I type the chat, the command into Dank
raid.
chat, do you think it'll work? Yeah? Okay, cool. It works with the same
The Twitch
API or whatever?
servers are what actually interpret it.
Okay. Oh, and Jack's Fax is online?
Oh.
I've never actually watched Jack's Fax live.
Cool.
Yeah, I'm sure he'd appreciate a raid. Let's see.
They don't want raids. Well, okay, Claire. Well, okay.
Alright, Jack's Fax doesn't want raids.
Jack's Fax doesn't want raids.
Well,
Okay.
don't dangle it in front of us, Claire. Gosh.
Marine Mammal.
Here's a person you shouldn't raid while you're looking for people to raid.
We will raid Marine Mammal Rescue, and we will go rescue some marine mammals. Or maybe
Perfect.
we'll use...
Maybe they will rescue us.
Maybe they'll rescue us.
Wow, that's deep.
Maybe we will call the U.S. Marines to rescue some mammals. But at any rate, we will get this started. Jack's Fax wants raids.
Oh.
Oh.
Oh my gosh.
Well, okay.
So many twists
I wish that were
and turns in
clearer.
this right now, Claire.
It doesn't matter. Let's raid
Yeah, it
whoever
doesn't even matter.
And
Let's
I don't think
raid
that
who you already have.
I don't
typed
think
in.
that worked with
Okay, Claire.
Did it work?
I don't actually see it, actually. Yo,
Yes,
Zooland Man,
yes.
thanks for hanging out.
It says raiding marine mammal
Okay,
rescue
great.
with 72
Okay.
viewers.
There's no place for me to click go or anything, so maybe it'll just go at the end of a timer. Look. I don't see anything there. It worked?
It worked.
Okay. I have no way to...
It says it's
it's going. I have no indication of that.
I'll let you know.
Okay.
Yeah,
thanks.
there's a timer. It's counting down. We have another, 30 or so seconds.
We do?
Yeah.
Oh, well, great. Thank you
Yeah.
so much, everybody, for hanging out with us.
This has been so much fun, everybody. Thank
Yeah.
you for the support and supporting us so we can do this kind of thing for you guys.
Absolutely.
With a great circle of love here on the Paleontologizing channel.
Yeah. Just really appreciate you, and I'm looking forward to bringing you some more museum content as laurdee and I drive back to California by way of Utah and Idaho and Arizona, and yeah, it's going to be
Streaming
cool.
Dream Team.
Okay,
Here we
this
go.
is it.
Okay, bye.
All right, bye-bye, everybody.
Bye, everybody.
Thanks for being here.
Okay, and now we go to our RTP server, and we...
Yeah, I can turn that off there. And
Whoever
stream.
didn't leave. Yes.
Okay. And then back to...
Nice.
Oops. Live view solo. Stop.